important topic of the day, which is nothing but definite integration. So, definite integration is going to be the one of the most important topic of the day. Okay, so those who are waiting for this, they should not be waiting anymore. We are available with most demanding topic, that's definite integration. You will be getting around 5 to 6 question every year in JEE means JEE Advanced or any competitive engineering examination. Okay, so this topic has its one weightage. So are you all ready with this? So are you all ready with this? Let's start with definite integration. Let's wait for our friend to join and then we'll start one shot. One shot. It is going to be one shot, okay? Well, we are going to cover every sets of questions, every sets of theory. So this is the very last moment where people could grab all the concept of definite integrations. Okay, so let's rating definite integration. Take a moment, we are going to start it very fast. So it's nothing but definite integration by Ankit Kumar. We are going to have definite integration, so nothing to wait. Now we are going to start with the most clarifying doubts and everything that generally comes to the students. So it's time for getting 100% marks in definite integration. So now it's time to begin, okay? We have waited for our students to come. Good morning, Pranav. Good morning, Pranav. Good morning, Rajdeep. So let's continue. So we are proceeding with the origin of definite integration. So we are proceeding with the origin of definite integration. So what happened initially? Initially we were thinking like how the term a to b fx dx got derived. Okay, how a to b fx dx got derived. Hello Jesse Victor, let's continue. So first what happened in initial era, like there used to be some discrete point on the plot, discrete point in the plot, this this. So we used to be told that calculate the area by these all plots. So what we used to do is that we used to try to draw a rectangle, a small rectangle, and find the area. Similarly, joining this small rectangle and finding the small area. So similarly keep on doing for this thing. Okay, and it used to be difficult finding length into breadth. So like this it used to be difficult, isn't it? So finding this type of length into breadth used to be difficult for us. So one of our scientists Newton gave a logic. Newton gave a logic that if we convert if we convert this discrete point into we convert this discrete point into a function fx, and then find some generalized generalized approach it will be helping us to find the sum. Okay, so what he did in this y explain, he came up with a graph, like for example y equal to fx, and our discrete point was this. Yes, like it was at a, it was a plus h, it was a plus 2h. So similarly it kept on going, and it was up to b and b minus h. And since this function was y equal to fx, at a, can we say that this height is fa, and this height will come out to be f a plus h, this height will come out to be fb. So what happened is that he told that definite integration is area under the curve in the given limit. So what he did, if you see, he found that definite integration to be fa into h, f a plus h into h, f a plus 2h into h, plus dot dot dot, f a plus n minus 1 h into h. And then he told that can we write this function as a summation r equal to 0 to n minus 1, and this is what f a plus rh into h. So now what he did, if we put x equal to a plus rh, can we say dx is equal to h into dr? So now what he did, in place of summation he brought integration, and in place of a plus rh he brought fx, and in place of h he brought d dx, in place of h he brought dx, and there was some conclusion on limit. So see, when r is 0, when r is 0, x it is a, and when r is n minus 1, x is nothing but a plus n minus 1, and h is nothing but b minus a upon n minus 1, which is going to be b. So we can say that when r is 0, x is a, when r is 0, r is n minus 1, it is b. So simply can we say that this integration is nothing but integration of a to b fx dx. So this is the way the origination of integration occurred. Okay. So this is the way the origination of definite integration happened. Okay. Now moving to Newton's Leibniz formula. Okay. So in Newton-Leibniz formula, he told that if differentiation of capital Fx by dx is equal to Fx, if okay, if it is this thing, then if we do integration of Fx dx a to b, it will be nothing but Fx a to b, and we can say that it is Fb minus Fa. Okay. And this definition is valid for any types of function. Okay, maybe continuous or discontinuous. Okay, so whether the function is continuous or discontinuous, this is going to be valid. This is going to be valid. Okay, so for example, we'll take some example. Take example, uh, differentiation of x square upon differentiation of x is equal to 2x. Yes, so integration of x square, integration 2x dx 1 to 2 is nothing but x square 1 to 2, which is 4 minus 1 equal to 3. So we can simply say, and if you could not get it, we have a very solid question. So this is the solid question which has come from JEE mains. This is the one of the previous question of JEE mains. Okay, so this is the solid question that has come from JEE mains. Okay, so now we'll try to solve this question. If d of fx is this thing, then if this is fx fk minus f1, then find the value of k. So what will happen? We'll write I equal to integration 1 to 4 3 x e to the power sine x cube dx. Yes, this is it. So what will happen is that we'll put x cube equal to t. We can have 3x square dx equal to dt. Now in this place we are not doing any changes on limit, but what we are going to do is that we are going to multiply here. 3 is there only, x square, and divide with x square. So x square into x is x cube, and it is e to the power sine x cube dx. Okay, now what will happen? This limit we don't know. Okay, for now we don't know this limit. Now can we see that it could be further written as 3x square dx is what? Dt, and x cube is t. Can we say e to the power sine t, and at the bottom x cube is t? Can we say that it has come to our this equation? Now we have to find limit. So x was from 1 to 4. Yes, x cube will be from 1 cube to 4 cube. So when x cube is t, the limit is from 1 to 64. So can we say that this limit is 1 to 64? And we know that integration of e to the power sin x by x dx is nothing but ft going from 1 to 64, which is nothing but f64 minus f1. If you compare with the given solution, it is nothing but fk minus f1. Can we say k is equal to 64? Okay, so this is the solid question from JEE mains. If you are able to solve this, you are done with it. Okay, so moving ahead. Now what will happen? Whatever notes which are going to come, yes, from every note we have a solid questions. Okay, coming in JEE mains and JEE advanced. So kindly focus and try to get those. Okay, so one of the important notes is, if integration from a to b fx dx is equal to 0, if fx dx is equal to 0, then the equation fx equal to 0 has at least one root in a to b. Okay, my saying is that, for example, if we take a function, okay, if we take a function fx, this is fx, okay, and we find this area fx dx from a to b. Okay, If you see this is positive, y is positive, x is positive, so this cannot be equal to 0. Yes, if you go with this, if you go with this, you see that this area is positive and this area is negative. So positive negative can be equal to 0. Yes. So positive negative can be equal to 0 from A to B. Can we say that in between A to B it has at least one solution in A to B? So this is what we are trying to say, okay? Okay. So for example, if we take, if we say that 0 to 1 e to the power x ax square plus bx plus c into dx is equal to 0. So from here can we say that there lies at least one root in 0 to 1 where ax square plus bx plus c is equal to 0. So can we say this thing? So now we will go to some questions, okay? So this is a question we are given. We are told that C note 1 this is equal to 0. C dot and C1 C2 are real and equation of this. Then the equation C2 x square C1 x plus C naught is equal to 0 has. So what will we do? We'll take a function, we'll take fx equal to C2 x square C1 x plus C naught. Okay. Okay. Now what will happen? We'll have I integration a to b fx dx. Okay. Which will further go a to b c2 x square c1 x plus c naught dx. Can we say that it is nothing but c2 x cube by 3 plus c1 x square by 2 plus c naught x, which is going from a to b. Now we will put a equal to 0, b equal to 1. So we'll find that it is nothing but c2 by 3, c1 by 2, c naught minus 0, and it is given that it is equal to 0. So we know that if integration is 0, that means there exists at least one root in 0 to 1, 4 fx equal to 0. So this is the definition taken from the previous question itself. So try to get this question very nicely, because after moving ahead, we are going to have JEE Advanced 2014 to 2024 question. Okay. So if you have any doubt, you can comment. Okay, I'm ready to see your comments. So this is the question taken from IIT Advanced 2024. IIT Advanced 2024. Okay. So now what is happening? We have given some good skill. Now what is happening? You see, this function is given from here, and if you see, this is nothing but from the basic definition of integration a to b fx dx equal to 0. If you are able to do so, you will get the answer. Okay. So now what will happen? This is ft n and n. Okay. So ft n and n. So n is natural. Okay. We'll try to first open this function. We'll do n equal to 1. We are going to get nothing but minus 1 to the power 2 with into 2. So this is 2 when t equal to 1. Yes. And the second is going to be t from 1 to 3. And this function is nothing but, if you see, it is, we'll put n equal to 1. It is 3 minus t by 2 into f1 plus t minus 1 by 2 f3. Okay. Now we'll put n equal to 2. This will become minus 2 and t will become 3, and the second part will become 5 minus t by 2 f3 plus t minus 3 by 2 f5. Similarly, we keep on moving. We have n equal to 3, so we are getting, let's see, it's a 2 minus 2 and then this. And here it was t minus 1, this. Now it will become what? 3, 5, 7. 7 minus t by 2 f5 plus t minus 5 by 2 f7. Yes. And this is t 3 to 5. This is t equal to 5. And this is t is 5 to 7. Now if you see it further, from here we are getting 2. From here what are we going to get? When t is from 1 to 3, f1 is what? This is f1. N equal to 1, t equal to 1. That means f1 is 2 and this is ft, where t is belonging from 1 to 3. This is what? f3. 3, and this is again ft, where t is from 3 to 5. This is f5, this is ft. Okay, now what will happen? f1 is 2, so can we say it's a minus 3 minus t, 2 divided by 2. f3 is minus 2, can we say it's 1 minus t, which is nothing but, if you see, it is going to be 4 minus 2t. From here we are going to get 3. From here we are going to get f3 is minus 2. So it's a t minus 5, and f5 is 2. So it's a 2t minus 8. Similarly, it's a 5. T equal to 5, it's a 2. And it is going to be 12 minus 2t. Okay, so you can see that it was 4, then minus 8, then 12, then minus 16. It will go like that. If you try to plot this on a graph, we are trying to plot this curve on a graph. So you see that at t equal to 1, it is 2. At t equal to 1, it is 2. And at t equal to 2, it is going to be 0. At t equal to 3, it is what? 4 minus 6 minus 2. So the line is going to be somewhere like this. Okay, wait. So this line has gone somewhere. Okay, this line is not getting deleted. But I wanted to say that the line will come out to be in this way. It will be this line connecting to this line. Okay. Now it will be again 5. So now at 3, it's a minus 2. At 5, it is again 2. So it will go like this. And again it will come like this. 7. And then it will again go like this. Okay. So we have to look only from 1 to 8. So we have to go only up to 8. Okay. So it is 1 to 3, this area, and then 3 to 5, this area, and it's a 3, 1 to 3, 3 to 5, 5 to 7, 7 to 8, 7, 8, 1, 2, 3, 4, 5, 6, 7, and it is 8, and this is 9. So what will happen? We have only these areas. Okay. 1 to 8. Okay. Now we are told that define gx 1 to x fx dx. Okay, that means 1 to x in between 1 to 8. So fx dx, x belongs to 1 to infinity. For alpha denote the number of solution of gx. So alpha denote the number of solution of gx in 1 to 8. That means it is 1 to infinity, in which we are going only from 1 to 8. So from 1 to 8, we have alpha number of solution. So this is gx, integration of fx dx 0 1 to 8. Okay, it is equal to 0. So the number of values for which gx is 0 from 1 to 8 is equal to alpha. So what is alpha? Okay, and this is x. x belongs to 1 to 8. Okay, now if you see, if we take x equal to 1 to 3, if x is 3, if x is 3, you see that this part is positive, this part will be negative, so alpha, it is going to be 0. When x is 5, when x is 5, you see that this area is positive, this area is positive, and this is negative, so overall they are going to be 0. When x is 7, it is again 0, because this part 9 minus this part minus this part minus, so overall 0. Now if you go ahead, we are not getting 0, so alpha, the number of solution for having 0 is what? It is only 3. So 3 values of x for which alpha is 0. Okay, now if you move ahead, we are told that beta is equal to limit x tending to 1 plus, is it so? 1 plus gx upon x minus 1. And it is seen that it is nothing but limit x tending to 1 plus integration 1 to x fx dx upon x minus 1. So when it is 1 plus, it is going to be 0. So applying L hospital, can we say that it is fx upon 1 and limit x tending to 1 plus? So can we say it is f1, and can we say f1 is 2? So if you try to find the value of alpha plus beta, it is nothing but 3 plus 2 equal to 5. So we got the answer. So this is JEE advanced question taken from just the basic derivation of integration a to b fx dx. If you know that, you know this question. Okay, let's move ahead. So we are trying to say that properties has much value. Okay, properties has much value. You can have very minute questions coming to JEE Mains and JEE Advanced. So kindly give high focus to this all. Okay. So now we are proceeding with second property. This property is saying that if we have something limit and tending to infinity, integration a to b fn x dx, then we can write this as limit a to b, and we can first solve the limit and tending to infinity fx, and then we can work with dx. Okay, this is what I am trying to say. Like if it is integration and then we have some function is in the form of n, like fx is in the form of x to the power n, okay, upon e to the power n, for example. Okay, so if we are given some function and we have to calculate 0 to 1, for example, we have to calculate fx is this. Okay, example, fx is x to the power n e to the power n. Okay, so what will happen if we do limit n tending to infinity 0 to 1 we are given. Okay, and it is x to the power n e to the power n dx. So what we can do is that we can first calculate the limit n tending to infinity and then solve it, or we can first find the integration. So in this question, okay, first what will happen, we'll try to find integration itself. Okay, so we'll send e to the power n out. It is 0 to 1 x to the power n dx, and finally we are going to get limit n tending to infinity 1 by e to the power n x to the power n plus 1 upon n plus 1, 0 plus 0 to 1, and it is limit n tending to infinity 1 by e to the power n. So this is 0 to 1, that is 1 minus h to the power n plus 1 infinity minus 0 upon n plus 1. So fraction to the power infinity is 0, so overall we are going to get 0. If we go with method 2, this is method 1. Okay, we followed this method 1. First we tried to find the limit, first we tried to find the integration, and then we went with the limit. Now second, we'll do integration later, and first we'll do limit n tending to infinity x to the power n e to the power n, and then we'll do dx. Okay, so what will happen, limit n tending to infinity, it is nothing but, if you see, limit n tending to infinity x to the power n upon e to the power n, it's like infinity by infinity. So we'll go with L-Hospital, we'll differentiate, it will come n x to the power n minus 1 e to the power n, it will stay the same. Okay, so this is still limit n tending to infinity. Again if you solve limit n tending to infinity, okay, we are going to get somewhere n minus 1 n minus 2 dot 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 1 upon e to the power n. Okay, now you see that expansion of e to the power n is nothing but n to the power 0 by 0 factorial plus n to the power 1 factorial. It will go up to n to the power n upon n factorial and something dot 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 n to the power n plus 1 upon n plus 1 factorial. So you will find that n to the power n is bigger than this n factorial. So we are going to have something uh, n to the power infinity upon infinity factorial. So if you see that this number is the denominator is going to be bigger than 0. Denominator is going to be very big number and this is very small. So it will come out to be 0. And now this value is coming out to be 0. And now we are doing integration of 0 to 1. 0 dx, which is c. Okay, so c is what? At 0, at 1 it is c, at 0 it is c, which is 0. So going through both the way is giving us the same value. Okay, so we are taking one of the suitable question. I would like you all to attempt this question first. Okay, so I would like you all to attempt this question. So now I am proceeding with this question. Okay, based on the previous example, now we are proceeding with this question. So this is limit n tending to infinity. So what will happen? Will come out with this. Okay, and we'll do integration later. First we are going to go with limit. Limit n tending to infinity 1 minus t cube by n to the power n, and then we have t square dt outside. So first we'll try to find this limit. So we are simply getting limit n tending to infinity 1 minus t cube by n to the power n. If you see, it is nothing but when n is 1 to the power infinity. So in 1 to the power infinity we do nothing but e to the power n ln 1 minus t cube by n, and we divide by minus t cube by n and multiply with minus t cube by n. Okay, and we have limit n tending to infinity. So if you know by standard limit, 1 minus t cube by n upon minus t cube by n, this is nothing but 1, and n will get cancelled, so we are simply getting e to the power minus t cube. Okay, so from here we are going to proceed this as minus root 3 a to the power 1 by 3 a to the power 1 by 3 e to the power minus t cube t square dt. Now if you remember is that if you see the limit, t is from minus a to the power 1 by 3 to a to the power 1 by 3. If you take t cube is nothing but from a to a. Now we are considering this as z, which is minus a to a, and if you remember dz is nothing but 3 t square dt. So in this we'll multiply 3 and divide 3. So 3 t square dt is what? Dz, and it is e to the power minus z, and limit is nothing but from minus a to a. So the integration is nothing but e to the power minus z minus a to a. So it is nothing but minus of e to the power a minus e to the power of minus a, which is plus e to the power minus a minus e to the power a, and it is told that it is equal to 2 root 2 3. Okay, so we will have to solve this normally. So we'll solve this normally. We'll get somewhere 1 by e to the power a minus e to the power a equal to 2 root 2 by 3. Okay. Now they are going to form a quadratic. So that quadratic is going to be formed as e to the power 2a plus 1 equal to 2 root 2 by 3 e to the power a. We have e to the power 2a plus 2 root 2 3 e to the power a plus 1 equal to 0. Can we say that e to the power a is minus 2 root 2 by 3 plus minus root under b square minus 4? This is not, this is minus e to the power minus 2a. It is minus 1, okay, it is minus 1. So this is going to be plus 4 upon 2. So if this is minus, e to the power a is positive term, so minus will get eliminated. So this are 44. So we are going to get e to the power a equal to 6 minus 2 root 2 plus 2 root 11. So a is nothing but ln root 11 minus root 2 by 3. So this is the value of a. Okay. So this is the way we solve the question. So this is just from the basic. Okay. Moving ahead. Now we are on property 3. We are on property 3. We are told that, so from these all small property you will have questions in JEE mains. Okay. So this is a to b fx dgx. If you remember, we have something going inside dgx. Okay, dgx. Then what can we say that? We can say that it is g inverse a to g inverse b fx g dash x dx. Okay. If you want proof, I am giving you proof. So if differentiation is with respect to gx, can we say that gx is between a to b? Now can we say that x is between, we'll take inverse g inverse a to g inverse b. So similarly we can say that it is a to b fx g dash x dx, where x is varying from a to b. Hence this is correct. Okay, let's take, so this is what I am trying to say. So if you want a small example, so small example, we are giving 1 to 4 fx as x d of x square. So what we did is that we kept, it is given that x square is between 1 to 4. We found x between 1 to 2. So we kept 1 to 2 x, differentiation of x square is 2x dx. And now we integrated. We got 2x cubed by 3, which is from 1 to 2. So it is 14 by 3. So G inverse is what? We know that if y is equal to x square, x is equal to root y, which is y equal to root x. So G inverse is root x. So inside root we sent the value 4. It was root under 4, which is root under 4. And this is root under 1. Okay. This is calculating of G inverse. Okay. I think you got it. Let's move ahead. So we are going with property number 4. Property number 4 we already discussed somewhere in Newton's Leibniz formula, and we consider this as a property again. That was Newton Leibniz was not continuous, but this is continuous. If fx is continuous in a to b, then integration a to b dy dx of fx is equal to fx a to b. Okay, and if fx is discontinuous at x equal to c in a to b, then integration a to b dy dx fx is integration a to c dy dx fx plus c to b dy dx fx. Okay, and you can simply say it is what? Fx a to c plus fx c to b. Okay, that's all. Okay, let's take a simple example. Integration minus 1 to 1 dy dx cot inverse 1 by x. Okay, so can we say it is simply cot inverse 1 by x minus 1 to 1. Okay, if you see, this is minus 1 to 1. Okay, this is minus 1. So this is minus 1. Okay, so if you find cot inverse at x equal to 0, it is not continuous. So we'll break this as cot inverse 1 by x minus 1 to 0 plus cot inverse 1 by x 0 to 1. So cot inverse 0 minus is minus infinity. Cot inverse minus infinity. If you see the graph of cot inverse, it is somewhere like this. Okay. So cot inverse minus infinity is something pi minus cot inverse minus 1 is pi minus pi by 4. Okay, plus cot inverse 1 is pi by 4, cot inverse 0 plus cot inverse 0 plus is pi by 2. No, 0 plus is infinity. At infinity it is 0. Okay, 0 plus is cot inverse 0 plus is infinity, which is what, 0. So if you see, it is nothing but pi by 2 is the answer. So it is pi by 2 as an answer. Any doubt, you can comment me. I will reply you with the answer. This is one and the last important notes for the lecture 1, and this is very solid. Try to get it into your mind. It will help you to get it. Okay. Point number 5. If gx is the inverse of if gx is the inverse of, so global trotter, get short notes from me, get short notes from me. Okay, so okay, so this is if gx is inverse of fx. Okay, and fx has domain. Okay, fx has domain x belongs to a to b, where fa equal to c, fb equal to d. Then See, gx is inverse of fx. That means gx is inverse of fx. Okay, and domain of fx is what? A to b, and fa equal to c, fb equal to d. Okay, these are the condition. These are the condition. Okay, condition given. These are the conditions which are given. Okay, then integration a to b fx dx plus integration c to d gy dy is equal to bd minus ac. Okay, then we have something like this. Okay, if you want, I will be giving you the proof. Whether you want or don't want, I would like to give you the proof. Okay, I would like you to give you the proof. Okay, now we have a to b fx dx. Okay, and we have c to d. Gy is what? F inverse y dy. Okay, now we'll put y equal to fx, y equal to fy. Can we say that it is y and this is d of fy? Okay, so y was from c to d. Now we put y was from c to d. We kept fy equal to y equal to fy, c to d. Can we say now y is f inverse c to f inverse d? And can we say that y is from f inverse c is nothing but a, and f inverse d is what? B. So can we say that it is now from a to b, and this is a to b fx dx. And if you see further, it is nothing but a to b fx dx plus a to b y f dash y dy. Further going, we are going to get a to b fx dx plus, we'll do by part here. First we'll take y common, integration of f dash y dy a to b, and then minus differentiation of y is 1, and then we have fy dy a to b. You will see that this and this is getting cancelled. We are simply getting y fy, which is a to b. So at b it is b fb minus a fa. So fb is what? D. Can we say it is bd minus ac? So we proved it. Yes. So we proved it. Let's move ahead. Now we have this question fx and gx with the inverse of f1 f5 2. So we can simply say that 1 to 5 fx dx plus 2 to 10 dy dy is nothing but 5 into 10 minus 2 into 1, which is 48. Since we know the formula, we directly applied here. Fx is this, gx with the inverse of fx, then which of the following hold good? So what will happen in the given function fx 0 to x dt upon root under 1 plus t cube, we will differentiate both the side. We will get f dash x equal to 1 upon root 1 plus x cube. Okay. Now which of the following holds good? If we take that gx is equal to f inverse x, we'll take g of fx equal to x. We'll differentiate by both the sides. G dash fx f dash x equal to 1. So g dash fx is equal to 1 upon f dash x. So g dash fx. So f dash x is nothing but root under 1 plus x cube. Okay. So what will happen? We'll differentiate it again. C double dash fx is 2 root 1 plus x cube 3x square. Okay. Okay. And it was dot f dash x also. Okay. So now f dash x is 1 by root under 1 plus x cube. So from here we are getting g double dash fx into f dash x equal to 3x square into f dash x, which is getting cancelled. Can we say that g dash fx, this is g double dash, okay, is equal to 3x square by 2. Okay. So what will happen? Uh, if we take f inverse s, g double dash f of f inverse x, we are going to get g of f inverse x whole square by 2. Yes. And if you remember that this is g double dash x is nothing but f inverse x is what? Gx, which is 3g square 2g double x. So this is what we are trying to get. So option number B is correct. My question is, if we put f equal to f inverse s, we are going to get 2g double dash x equal to 3g square x. Okay. Okay, this much I was going to leave. Okay. So from here I am taking, okay, g double dash fx is equal to 3x square by 2. Put x equal to f inverse x. We are going to get g double dash f of f inverse x, which is equal to 3 f inverse x whole square by 2. This is what g double dash x 3 by 2. F inverse x is nothing but gx whole square. Can we say that 2 g double dash is equal to 3 g square, which is option B. Moving ahead, now we have come to definite integration in terms of indefinite integration. So definite integration in terms of indefinite integration. So this has nothing, okay. What we are trying to do is that first we'll solve any function as indefinite integration and then put the value. Like if we have a to b dx upon 1 plus x square, we are simply going to solve first dx 1 plus x square. We are going to get tan inverse x. After we got this, we'll put a and b. Okay, we are going to get tan inverse b plus c, so we are going to get tan inverse b plus c minus tan inverse a plus c. So it is nothing but tan inverse b minus tan inverse a. So this is what I am trying to say you all. Okay, so definite integration as a substitution. First solve it in definite integration and then substitute the value. This is what I am trying to say. Okay, now this is what we are going to do. First we'll solve this as definite indefinite integration and then we'll put the value. So this is dx x plus 1 x plus 2. We'll do simply x plus 2 minus x plus 1 upon x plus 2 into x plus 1 dx, which is nothing but dx upon x plus 1 minus dx upon x plus 2. This is dx upon x plus 1 is what? Ln x plus 1 minus ln x plus 2. The limit is from 1 to 2. It will come out to be ln 3 minus ln 4 minus ln 2 minus ln 3. It is somewhere 2 ln 3 minus ln 4 by 2, which is nothing but ln 9 by 2. Okay, so we solved as a indefinite integration and just kept the values. Now if we are going with this, first we'll solve it as indefinite integration. Okay, in this, how should we proceed? We'll we'll have something I by 5 equal to x square dx upon x square plus 4x plus 3. And if you want to see something, it is nothing but x plus 1 into x plus 3 dx x squared. Try to create the difference. It is like x plus 3 minus x plus 2, and we have x squared dx upon x plus 3 x plus 2. So if you see, this is going to be 2, we'll multiply with 2 and multiply with 2 this side. And if you try to open this, it is nothing but x square dx upon x plus 2 minus x square x plus 3 dx. Now what will we do? We will move this side. We have 2I by 5. In x square, we'll minus 4 plus 4 plus 4, and we have x plus 2 dx, and here we'll have minus 9 plus 9. So if you fragment this, it is nothing but x minus 2 dx plus 4 x plus 2 dx minus x minus 3 dx minus 9 x plus 3 dx. It is x minus 2 whole square by 2 4 ln mod x plus 2 minus x minus 3 whole square by 2 minus 9 ln mod x plus 3. Now what will happen in this? We are going to substitute 1 to 2. So we solved it as indefinite integration. Now we are putting the value. When it is 2, it is nothing but 4 ln 4 minus 1 by 2 minus 9 ln 5. When we put minus, it is minus of 1 by 2 4 ln 3 minus 2 minus ln 4. Okay, so it is nothing but 4 ln 4 minus 1 minus 9 ln 5 minus 4 ln 3 plus 2 plus 9 ln 4 multiplied with 5 by 2. So this is I. So we have to proceed in the same manner. Okay. Now proceeding ahead with the same similar examples. So this is, we'll take it as I 0 to pi by 4 to sec square x dx plus 0 to pi by 4 x cube dx plus 0 to pi by 4 2 dx. This is 2 sec square x dx is 10x. 0 to pi by 4. This is x to the power 4 by 4. 0 to pi by 4. This is 2x. 0 to pi by 4. It is nothing but 2. This is pi by 4 to the power 4 by 4. This is pi by 2. So this is the answer. Okay, I think you got expert in this. You all got expert in this. So we have to know the substitution. Okay, so we are given that I1 is this e2 e square dx upon ln x. Okay, so we are looking that x is from e to e square. If we take ln all the sides, can we say ln x is from 1 to 2? Now we'll take ln x at z. We'll do dz, which is what? Dx by x. We know that x is, if z is ln x, x is what? E to the power z. So dx is what? E to the power z dz. So in this what will happen? Dx could be written as e to the power z dz, and ln x could be written as z, and limit will convert from 1 to 2. Can we say that it is nothing but 1 to 2 e to the power x by x dx, which is nothing but I2. So can we say that I1 is equal to I2? Okay, moving ahead. Anyone who are online, they are facing any doubt, kindly ask me. Okay, okay. Now, after substitution, we are going with some miscellaneous questions. Okay, so let's start with one of the miscellaneous questions. First question is 0 to 2 greatest integer x square dx. Okay, those who wanted to be expert in this, kindly solve these questions first. First, solve these questions. So, see how to solve this type of question. We have y, we have x. Okay, we'll draw x square. Okay, we have drawn x square. Now see, at from 0 to 1, the curve has value 1 only. So in this area, there is 2. At 2, it has value 4. Okay, so at 1 it is 1. At root 2, it will have value 2. At root 3, it will have value 3. Okay, add 2, it will have value 4. Okay, so we are drawing the graph of greatest integer. So from 0 to 1 it is 0. From 1 to root 2 it is 1. From root 2 to root 3 it is 2. From root 3 to 2 it is 4. Can we see that this is the area we are getting? This is the area we are getting. This is the area we are getting. So we are getting nothing but integration 0 to 1, 0 dx, integration 1 to root 2. We are getting what? 1 dx. This is 1 and this is 1 to root 2. Yes. And from here we are getting root 2 to root 3 as 2 dx, because from root 2 to root 3 it is what? 2. Greatest integer is 2 and then dx. And then root 3 to 2 we are getting 3 dx. If you solve this, this is 0, this is x, which is root 2 minus 1. It is 2 into root 3 minus root 2. This is nothing but 3. 2 minus root 3. You can calculate the sum and get the value. Okay. Second one, we are doing integration 0 to pi root under 1 plus sine 2 pi x dx. Okay. If you see, we can write this as simply as root under sine pi x plus cos pi x whole square. It is 2x only. We did 2 pi x. No, it is 2x. Okay. So this is 1x. Okay. 1x sine x plus cos x whole square and dx. Can we say it is 0 to pi mod sine x plus cos x dx? Yes. Got it. So we'll divide by root 2, multiply with root 2. 0 to pi, can we say it is nothing but sine x plus pi by 4 dx? So you will find that from 0 to 3 pi by 4, it will become sine pi by 4 to sine pi, which is positive. And from 3 pi by 4 to pi, it is negative. Three pi by 4 to pi, it is negative. Okay. So it is simply nothing but root 2 minus cos x plus pi by 4, and this is plus cos x plus pi by 4. Here the limit is going from 3 pi by 4 to pi, and this is 0 to 3 pi by 4. If you solve it further, it is root 2 At 3 pi by 4 it is minus 1. Cos minus 1 is 1. And at 0 it is 1 by root 2. And at pi it is pi plus pi by 4, which is minus 1 by root 2. And at 3 pi by 4 it is minus 1 plus 1 is 1. So it is nothing but 2 root 2. Okay, I am just trying to say you this. So now let's move to third question. So if you are moving to third question, it is fx given as two function 2x plus 1, x 0 to 1 maybe, and x 1 to 2. This is 3x square plus 1. Okay, it is 3x square. So integration 0 to 1 2x plus 1 dx, integration 1 to 2. So we are breaking the functions. Okay, so it is nothing but we are doing 2x dx 0 to 1 plus 1 dx 0 to 1 plus 1 to 2 3x square dx plus 1 dx 1 to 2. This is x square by 2, which is x squared 0 to 1, x 0 to 1, it is x cube by 3, which is x cube 1 to 2, x 1 to 2. So this is simply 1, this is 1, this is 8 minus 1 plus 2 minus 1. So we are getting what? 10 as answer. So this is the way, if the function is discontinuous or some different, how will we break? This is how we can break it. Okay, moving to fourth question. We have mod of x square minus 4x plus 3. 0 to 4 mod of x square minus 4x plus 3 dx. So what will happen if you try to draw this graph? It is x minus 1 into x minus 3. So it is going somewhere like this. So this is 1, this is 0, this is 1. Okay, it will be x equal to 1, x equal to 3, and 0 is here. Okay, 0 is here. So this mod will convert into like this, and it will go like this up to 4. So what can we do? We see that this function is 0 to 1 x square minus 4x plus 3 dx plus 1 to 3, it is coming out to be negative, x square minus 4x plus 3 dx 1 to 3 plus integration 3 to 4 x square minus 4x plus 3 dx. So this is what? X cube by 3 minus 4x square by 2 plus 3x 0 to 1, and here we'll get minus will come out, and it is the same thing, x cube by 3 minus 4x square by 2 plus 3x 1 2 3 plus x cube by 3 minus 4x square by 2 plus 3x 3 2 4. So we'll put the value. At 1 it is 1 by 3 minus 4 by 2 plus 3. At 0 it is 0 minus 3 cube by 3 is 9. 2 into 3 square plus 9 minus of minus 1 which is plus 1 by 3. This is minus 1 by 3, okay, and plus 2 minus 3, and here we have 4 cube by 3, 2 into 4 square, 3 into 4 minus 9 plus 2 into 3 square minus 9. So if you solve it, the sum, you will get the answer. Okay, solve the sum, you will get the answer. On fifth question we are moving ahead. Okay, this is the fifth question. 0 to infinity greatest integer cot inverse x dx. So we are going with graphical way. We have y, we have x. Cot inverse graph is somewhere like this. Okay, this is pi, this is 0. So 0 to infinity. At this is what? This is pi by 2. And there will be some value 1. And after this, 1 onwards, it is going to be 0. Okay, so from here we have 1, so we have 1. Okay, so this is the area and this is the area we have to find. So by graphical it is simpler to solve. So we can get that the value at which cot inverse is 1 is nothing but cot 1. Okay, so area is simply what? If you see the rectangular area, so rectangular area is nothing but cot 1 into height 1. So this is cot 1. That's all. By pictorial we can find area under the curve. Now question number 6. Question number 6 is minus 5 to 5. Mod of x plus 2 dx. Okay. So what will happen? We'll go with the graph again. So x equal to minus 2, it is 0. And it will go somewhere like this. At x equal to 5, it is 7. X equal to minus 5, it is 3. we have to find area of this thing. So how to find this area? If we see this area, it is nothing but half base. Base is 3, height is 3. And if you see this area, this part area, half 7 into 7. Yes, it is nothing but 49 plus 9, 58 by 2, 29. This is the answer. Now seventh one, cos inverse 1 minus 1 to 1. Seventh one is greatest integer cos inverse x minus 1 to minus 1 to 1, greatest integer cos inverse x dx. So we'll first plot the graph for cos inverse x. Cos inverse will come out to be somewhere like this. 0 to pi. This is minus 1, this is 1. Now what will happen? It is pi by 2. Pi by 2 is 1 plus this is 3. So there will be some number 3. There will be some number 2, some number 1, and then 0. This is pi by 2. So pi by 2 is 1 point something. Okay. So from pi to 3, can we say that it is 3? From 3, from 3 to some curve value where it is touching, like at 2 it is touching, it is 2. From 2, so on the curve there is some value 1, it is going to be 1, and from 1 it is 0. Okay, so we have to find this area, this area, this area. Okay, so by graphical we are able to visualize, so finding it is easy or not. So when it is 3, when cos inverse is 3, can we say that it could be broken into minus 1, minus 1 to cos 3? It was 3 dx plus cos 3 to cos 2. It is 2 dx. I mean, this point is going to come out as cos 3. This point is coming out to be, this is cos 3. This point is cos 2. This point is cos 1. So simply from cos 1 to cos 2, it is 1 dx, and other than that it is 0, cos 1 to 1. So we have simply 3 dx, which is 3 cos 3 plus 1, 2 cos 2 minus cos 3 plus cos 2 minus cos 1. Okay, so we are further getting 2 cos 3, 3 cos 2 plus 3 minus cos 1. So this is the answer we are going to get from last question. So let's move ahead. Now here we will be looking at where the substitution is being used. Okay, so you see that this is a function 1 and 2. This is x to the power 2x square. We'll have x, which will go here, x plus 2x ln x dx. We'll put t equal to x to the power 2x square and we'll differentiate. So while differentiating, it will become d to the power e to the power 2x square ln x. When you differentiate, it is nothing but x to the power 2x square. It is 4x ln x plus 2x square by x dx, which is x to the power 2x square, 4x ln x plus 2x dx. So if we take 2 common, it is x to the power 2x square, 2x ln x plus x dx. So you see that this term is available with us, isn't it? So can we say that it is nothing but some variable from here to here, and it is dt by 2, which is nothing but t by 2, and t is what? X, 2x square by 2, 1 to 2. At 1 it is 1, at 2 it is 2 to the power 8 minus 1 by 2. Okay, so by part is something like if we have some function a to b fx dot gx dx, we consider one function as 1, second as 2. Have will integrate fx dx, and we have gx here, minus will differentiate this one, and we have integration of fx dx, and we'll integrate with this. So this is the way we perform by part. I think you remember from integration, indefinite integration. This concept is taken from indefinite integration. So you may be knowing this from indefinite integration. Moving ahead. So in this question we are going to apply by part. Okay. So I is equal to 0 pi by 3 x 1 plus sec x dx. Okay, we'll multiply and divide with sec x minus 1, sec x minus 1, 0 to pi by 3. So we are going to get nothing but sec square minus 1 is 10 square x, x sec x minus 1 dx. It is 0 to pi by 3 x sec x tan square x minus x tan square x dx. Okay, so if we go further, it is 0 to pi by 3 x. This is sin square cos square, which is cos x by sin square x dx, and this side we have x cot square x dx. Now in this we'll consider this as first function, this as second. So we'll put second out, integrate first one, and then differentiate the first one and we'll put the integration one. So if this is t, this is dt, so this is minus 1 by sin x. So this is minus 1 by sin x, which is minus cosec x. And here we have minus x. We'll write cot square x as cosec square x minus 1 dx. Here we got minus x cosec x 0 to pi by 3. Here we got plus ln cosec x plus cot x 0 to pi by 3. Here we have minus x cosec square x dx plus x dx. Going further, from here if you calculate, it is minus x cosec square x minus cosec square x is minus cot x. Okay, and then plus integration of cot x, and here we are getting pi by 3, so minus pi by 3 pi by 3 cosec pi by 3 60 degree 2 by root 3 at 0, it is x by sin x, which is minus 1 plus 1, and this will come out with some value. So we'll check that value. Right now we are solving this thing. Okay, cot x dx, and this is x square by 2, so 0 to pi by 3. This is ln sin x. Okay, this is ln cosec x is 2 by root 3. This is 1 by root 3. So this ln sin x and sin x coming out of this will get cancelled. Okay, and we have pi square by 9 into 2. So you can calculate this value easily. Okay, I was just showing how to do pi part. So this is second lecture. Now from here the property will start. It will go up to 11 properties. So that is all about definite integration. So right now we are giving you 1 minute of break, and then we'll continue. 1 minute of break. Now it's time for property, okay? In order to give you all the visualization of your past, like indefinite and definite, you have to go through something like that, okay? Hmm. So we are on property one. Property one is saying simply that if we are integrating a to b fx dx, it could be told that we are doing a to b ft dt. That means these internal variables are independent. We can write this as a to b fz dz. So internal variables are independent of external variable. This is what it is trying to say. Okay, this is it. So if you want a simple example, I will be saying that if integration is written as 1 to 2 x square by 2 plus x dx, we can say that it is written as 1 to 2 z square 2 plus z dz. This is what we are trying to say. And basically we will solve this as indefinite integration and then finally substitute the value in that equation. Property 2. Property 2 is saying that if we are finding integration a to b fx dx, then in case we change the limit from b to a fx dx, it will get multiplied with minus. On reversing the limit, the value of integration gets multiplied by -1. Okay. Okay, boss. For example, we do integration 1 to 2 x dx, and we would to find integration 2 to 1 x dx. So from here we are getting x squared by 2, 1 to 2, which is nothing but 4 minus 1 by 2, which is 3 by 2. If we try to find this, it is x squared by 2, 2 to 1. So what are we doing? We are doing simply 1 minus 4 by 2, which is minus 3 by 2. So did you get the concept? I think you got the concept. So this is the concept. Now we are going to calculate move ahead. So this is it. One of the solid example, okay? Now what will happen? It is somewhere 0 to 2, 2x plus 1 dx plus 2 to 5, 2x plus 1 dx. And if you reverse it, can we say it is integration 2 to 5, 2x plus 1 dx? So this is going to get cancelled. This is RHS. Can we say this is equal to LHS? That's the proof. Now in this, fx is this thing a to b. Okay. So a to b fx, which is ln 1 minus sin x upon 1 plus sin x dx. If we change the limit, we have minus of b to a ln 1 minus sin x 1 plus sin x dx. We'll take this minus inside. This will go minus 1 to the power of this much. Can we say it is b to a ln 1 plus sin x upon 1 minus sin x dx. So we could prove it from here to there. Property number 3. Property number 3, we already know that if a function is discontinuous at x equal to c, we'll break it into two parts. Like if we are doing integration a to b fx dx, we can do it as a to c fx dx plus c to b fx dx. We can say that fx is discontinuous at x equal to c in a to b. So my saying is that if we have a function like this. At C it is discontinuous. Can we say this is area from A to C and C to B? That's all. So I think we covered this question somewhere, otherwise we can cover here. So this function is 2 to 5 fx dx, which is when x is less than 3. That means when x is 2 to 3, it is x plus 3 dx. When x is 3 to 5, bigger than equal to 3, it's 3x square plus 1 dx. Now this is what? X plus 3 whole square by 2, 2 to 3. Okay. Yes, I know NIMSET. It is for those who wanted to go for JEE, NIT for MTech. Okay, it's not for BTech. And this is what? 3x square dx plus dx integration 3 to 5, 3 to 5. So add 3, it is 6. 6 whole square minus 5 whole square by 2. This is x cube by 3. So 5 cube minus 3 cube. And this is 5 minus 3. You can find this sum, you will get the value, isn't it? Moving ahead, x equal to 2 to 5, x minus 5. So we can, this is continuous at every point, but what will happen when you see the graph? At x equal to 5. So this was somewhere x minus 5, yes? So it is mod. So this will become somewhere like this. So add 2 and up to 8. We have to go. So if you see by picture, at 2 the value is going to be 3. At 8 the value is going to be 3 again. Okay. So this is also 3. By picture it is not appearing, but this is also 3. Okay. So if you find this area and this area, it is enough. The integration is enough. So this is nothing but half base into height, half base. This is base is what? 8 minus 5, which is 3, and height is 3. It is nothing but 9. Okay. This type of question we have to solve using graph only. This integration could be broken into 0 to 4 mod x minus 1 dx plus 0 to 4 mod x minus 3 dx. So what will happen if you go with this curve? X equal to 1 up to 4. This curve is somewhere like this. Yes, MCA, NIMSET is for MCA. So this will go up to 4 and it will go up to 0. So this area we have to calculate. This got cancelled and it got reflected. So at 0 it is 1. So this area is what? Half. Yes. So this is half into base into height. half, base is 3, and at 4 this value is what? 3. Similarly for this one, at x equal to 3 it is 0, at x equal to 4 it is going to be 4 comma 1, at x equal to 0 it is going to be 3. So we have to find this area and this area. So I think this is inverse of this one. If you see, it is half base into height, and this is half base is 1, height is 1. So we got somewhere this is 1 square plus 3 square, which is nothing but 10. Taking multiple cases will come out to be really difficult. So I think you all are getting how we got this graph. Moving ahead, greatest integer minus 2 to 4. So I have taken these all basic concepts to just make you understand of everything, isn't it? So minus 2, minus 1. So mm, minus 2, x is minus 2, yes. X is minus 2, minus 1. So minus 2 to minus 1, it is minus 2. Minus 1 to 1, it is minus 1. 0 to 1, it is 0. 1 to 2, it is 1. 2 to 3 is 2. 3 to 4, it is 4. 3 to 4, it is 3 only, okay? So this is what we have drawn is greatest integer function. We have plotted, okay? At minus 2, it will be minus 2, okay? It will be dotted minus 2. It is going like this. So we have just plotted it, okay? This is minus 2, minus 1, 0, 1, 2, 3, 4. We have to find these areas, okay? Uh, so we have to simply integrate. So if you see this area is negative. This is what? Base into height. This is minus 2. This is minus 1. Base is 1. Height is minus 2. So this is minus 2 area. This area is minus 1 area. This is plus 1 area. This region is plus 2 area. And this region is, this is 1. This is 2. This is 3. This is plus 3 area. So if you find total, okay, integration minus 2 to 4 greatest integer x dx, you are going to get minus 2, minus 1, plus 1, plus 2, plus 3. So all are going to get cancelled. Final answer is 3. So this is the way we can approach any question, okay? Now this is the question. We have to again plot the graph. It's a 0 to 9, okay? So y equal to x square. This is y equal to x square. Uh, Root x equal to y square. So this is somewhere going, okay. This is going to be y equal to x square. Like this, okay. This is root t, okay. So it is going up to when t is 9, okay. So how to break it into greatest integer, okay. So what will happen? 0 to 1. We are going to have 1. 1 to 4. It is going to have, this will come out to be 1 to 4. It is going to be 1 to 2, which is 1. And 4 to 9. It is going to be of this way, isn't it? So the greatest integer mapping, how is it happening? I wanted to just make you see this, okay. So 0 to 1, it is going like this. From 1 to 4, it is 1. At 4 to 9, it is 2, okay. So we have to simply find these areas. So integration 0 to 9, greatest integer root t, dt is what? This area is 0, this area is 3 into 1, this area is 5 into 2, which is nothing but 13, okay. Now if you fall to this question, so how to open the mod, okay. So what will happen? Let's plot on the curve. So it is 1 plus, this is 1, and from there we are doing 2 cos x. So at pi by 2, it is going like this. At 0, cos 0, it is 3. At pi by 2, it is 1, okay. So what can happen is that at cos x equal to minus 1 by 2, it can be 0. So minus 1 by 2, cos x is minus 1 by 2 at pi minus pi by 3, which is 2 pi by 3. So it can become 0, and cos pi plus pi by 3, which is 4 pi by 3, okay. And 4 pi by 3 is pi plus pi by 3, isn't it? So we are going only up to pi. So this part will become like this. Okay, so our integration will open something like 0 to 2 pi by 3 1 plus 2 cos x dx plus 2 pi by 3 2 pi minus of 1 plus 2 cos x dx. So I think now you all got how to open the bracket, how to perform integration. So these all are the basic question which can come in JEE mains. Okay. So if you try to see 1 dx is x, 0 to 2 pi by 3, and this is 2 cos x which is 2 sin x, which is 0 to 2 pi by 3, and we have minus x 2 pi by 3 2 pi, this is minus 2 sin x 2 pi by 3 2 pi. Now let's substitute the value. 2 pi by 3 sine 2 pi by 3, it's like root 3. Okay, sine 2 pi by 3, it's a root 3. This is pi minus 2 pi by 3, which is pi by 3, which is minus pi by 3, and this is minus 2. Sine pi is 0, and minus of minus plus root 3. Okay, so I think we are going to get only pi by 3 as an answer. So it's a pi by 3 only. Okay, now this type of question you are expert already in finding those, like we'll have I equal to minus 1 by 3 greatest mod of x minus 2 dx plus minus 1 by 3 greatest integer of x dx. So we have solved such type of function and such type of function. So you solve this as a homework. This question I am trying to take y x at e to the power minus x is somewhere like this. So when x is 0, it is 2. When x is uh, ln2, x is ln2, it is 1. And then let's, everything is there. So 0 to ln2, okay, it is going to have, at 0 it was 2, and then it is going to have something like this, and then it's a 0. So we have to find this area normally. So area we can say, or 0 to infinity 2 e to the power minus x dx is nothing but, this is 1, yes, 1 into ln2, base into height. ln2 is the answer. Now this type of question is there. Okay, so minus 2 to 4, if we say minus 2 to 3 fx dx, it will come out to be minus 2 whole square. We'll do minus 2 to minus 1, yes, minus 1 to 0 fx dx will come out to be 1. 0 to 1 fx dx will come out to be 0. 1 to 2 fx dx will come out to be 1. 2 to 3 fx dx will come out to be 4. 3 to 4 fx dx will come out to be 3 square, which is 9. So integration minus 2 to 4 fx dx is nothing but 4 plus 1 plus 0 plus 1 plus 4 plus 9, which is what, 8, 9, 18 plus 1, 19. This is it. Okay. This is a solid question I have picked up for you all. For example, I am giving you this question as board advanced question. Okay. So what will happen? 0 to 1 by 6. Okay. This is 1 by 2. This is 1 by 6. 1 by 3. Can we say it's 1 by 6? 1 by 6 will be having factor of 1 by 2 and 1 by 3 both. So we have broken it into 1 by 6 smaller part. So 0 to 1 we have 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, 6 by 6. Okay. Okay, got it. Now how those line will would appear? This is our trick. Okay. So 0 to 1 by 6. 0 to 1 by 6, this is going to be 2 by 6, which is a fractional thing. At 1 it is going to be 2. Okay. So it is fraction up to that much, isn't it? This is also fraction. 1 by 6 to 2 by 6, this is fraction, and both are fractions. Okay. So let's write in this way. Okay. 0 to 1 by 6. It is less than 1, so it will come out to be the same as it is. Okay. What will happen for fractional 2x? One by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, 6 by 6. So 1 by 6 will be giving it how much? 1 by 3. Okay. So it will be somewhere coming out to be y equal to x only. Like it is at 3 by 6, which is 1 by 2. It is going to be like this. Yes. It is going to be 1. At 3 by 6 it is going to be 1. At 6 by 6 it is going to be 1. And 4 fractional 3x, it is going to happen like x 3 by 6 is the place where it is going to have 1, and then it will go 1 at 6 by 6. No. At 3 by 6 it is going to be 3. At 1 by 3. At 1 by 3 it is going to be 1, which is at 2 by 6 it is going 1. At 3 by 6 it is going to be 1. At 4 by 6, 4 by 6. Okay. And at 9 by 6 it is going to be 1. No, 2 2 जा 4, 4 4 जा 6. Add 6 by 6. So 2 by 6 if you put, it is going to be 1. 4 by 6 it is going to be 2. 6 by 6 it is going to be 3. So what will happen from 0 to 2 by 6? This is going to come out as y equal to 3x. From 2 by 6 to 4 by 6 it is going to come out as y equal to 3x. Y equal to 3x minus 1. Okay, and this is going to come out as y equal to 3x minus 2, and from up to 3 by 6 it is going to come out as y equal to 2x, and this will come out as y equal to 2x minus 1. So the small breakup is at 2 by 6. Okay, so 0 to 2 by 6 it is 2x minus 1, and it is 3x minus 1. Like that, the fractional 2x is going to come out as 2x, and the fractional 3x is going to come out as 3x. Okay, now 2 by 6 2, 3 by 6, it is again 2x minus 1, but 2 by 6 to 3 by 6 it is going to be 3x minus 1 minus 1. So I think you got the difference. Now 3 by 6 to 4 by 6, it is going to be 2x minus 1 minus 1, which is 2x minus 2, and this is 3x minus 1 minus 1. And now no, there is no wrong, Satya. From 4 by 6 to 6 by 6 now. 4 by 6. 4 by 6 to 6 by 6. It is 2x minus 2, and it is 3x minus 3 dx. So Satya, we are not wrong anywhere. Tell me, where are we wrong? So this integration is going out to come as nothing but 0 to 1 by 3, 2x minus 1, 3x minus 1 dx plus 1 by 3 to 1 by 2, 2x minus 1, 3x minus 2 plus 1 by 2 to 2 by 3, 2x minus 2, 3x minus 2 dx. Okay, plus 2 by 3 to 1, 2x minus 2, 3x minus 3 dx. So I think you have to integrate. Now you know simply to expand it and integrate it. It is a quadratic, you can integrate. So breaking it into a simpler form was a bit a challenging work. We could do it, so it's a simpler. तो सत्या कहाँ गलती हो गई? गलती कहीं नहीं हुई, बताओ सत्या. अब हम लोग इस क्वेश्चन पे आते हैं, है ना. तो देखो, अब अगला क्वेश्चन जो है वो 0 to 100 है, एफ एक्स डी एक्स इक्वल टू ए, और हमें ये करना है. तो अगर हम लोग जब r इक्वल टू 1 रखेंगे तो ये 0 to 1 होगा एफ एक्स डी एक्स. अब 1 to 2 जब रखेंगे, r=2 जब रखेंगे ये हो जाएगा f1+x dx, है ना। अब जब 3 रखेंगे r3 होगा तो 0 to 1 f2+x dx होगा। इसी तरह यह चलता जाएगा और 0 to 1 100 पे ये f99+x dx होगा। तो देखो यहां पर x 0 to 1 है ना, तो x+1 क्या होगा, वो 1 to 2 होगा, है ना। तो क्या हम इसे लिख सकते हैं 1 to 2 fz dz। सिमिलरली x+2 2 to 3 होगा, तो क्या हम इसे लिख सकते हैं 2 to 3 fz dz। तो इसी तरह हम लोग आगे बढ़ते जाए समेशन करके, तो ये क्या x+99 क्या होगा 99 to 100 होगा। तो इधर से हम लोग ये बोल सकते हैं ये 99 to 100 fz dz होगा। और ये क्या है 0 to 1 fx dx। तो क्या हम इस सारी सम को ये बोल सकते हैं ये 0 to 100 fx dx लिखा हुआ है, जो कुछ नहीं बल्कि a के बराबर है ना। तो इस तरह से हम लोग कोई भी ट्रिकी क्वेश्चन को मेंस लेवल पर लाकर फोड़ते हैं, है ना। अगर हमें फोड़ना है तो हम ये करते हैं। कोई डाउट हो तो कमेंट करो, ओके। और हम यहां पर है आपके साथ, है ना। अब ये क्वेश्चन हो गया। अब f(x = 0 when n+1, ओके। तो ये एक इंपॉर्टेंट कंसेप्ट है जो जेईई मेंस में आ सकता है। इसको हम लोग थोड़ा प्लॉट करके देखते हैं ना। ये है 1 और ये है 2। तो अगर ये होगा कि x 1 से बड़ा होगा तो ये फ्रैक्शन पार्ट है, मतलब ये 1 से छोटा में ही आएगा ये फ्रैक्शन पार्ट। और जैसे हो गया 1/2, है ना, 1/2, 2/3, 5/6, इस तरह के टर्म 0 होंगे। और इसके अलावा सारे टर्म ऐसे होंगे 1 1 1 1, ऐसे ऐसे 1 1 1 1 1 ऐसे होंगे, है ना। और इसके बाद वाले जितने भी टर्म होंगे वो स्ट्रेट होंगे, वो एक स्ट्रेट लाइन होंगे, क्योंकि ये फ्रैक्शन तो बचा नहीं। तो 1 से 2 हम लोग इसको 1 dx मान सकते हैं, है ना। ये एरिया 1 dx हो गया, जो 1 के बराबर आ गया, बेस इंटू हाइट। और इस एरिया में कुछ ही पॉइंट्स होंगे जो 0 हो रहे हैं। ओवरऑल ऑलमोस्ट सारे पॉइंट्स, है ना, सारे पॉइंट्स। नहीं तो हम लोग इसे ऐसा बोल सकते हैं कि ये 0 to 1 है, 0 to 1 है ना। और ये fx dx है। तो हम इसे मैथमेटिकली ये बोलते हैं 0 to सम नंबर 1/2, पहला n इक्वल टू 9 हो, n इक्वल टू 10, n इक्वल टू 1/2, ये 1 dx हो गया। फिर 1/2 टू 2/3, ये 1 dx हो गया। तो तुम देखोगे कि सारे इंटरवल जुड़कर, तो ये सारे इंटरवल जुड़कर लगभग ये 1 dx 0 to 1 आ रहे हैं, और यहां पे 1 dx था, है ना। तो क्या हम लोग ये बोल सकते हैं 0 to 2 ये 1 dx हो गया, जो कुछ नहीं 2 के बराबर हो गया। तो इस तरह के बहुत डेप्थ वाले क्वेश्चन, दिस इज वेरी गुड फॉर जे मीन्स 2025 का बहुत ही शानदार क्वेश्चन हो सकता है ये। इसको नोट डाउन कर लो, ये बहुत ही शानदार क्वेश्चन हो सकता है जिसके आंसर 2 आ रहे हैं। अब ये क्वेश्चन है ना, इसे I1 मान लेते हैं, इसे I2 मान लेते हैं। तो I1 इज 1/e 10x t अपॉन 1 + t² dt। तो हम लोग जानते हैं कि इसे 2 से मल्टीप्लाई करो, 2 से डिवाइड करो, ये z dz हो जाएगा, जो कुछ नहीं 1/2 ln z, और ln z कुछ नहीं 1 + t² है, और इसका लिमिट 1/e टू 10x है। और अब इधर क्या होगा, ये I2 हो गया, तो I2 1/e cot x, और इसमें से t² कॉमन लेते हैं, तो ये t³ हो गया, ये dt हो गया, ये 1/t² + 1 हो गया। तो अगर हम लोग 1 + 1/t² को z लेते हैं, तो dz क्या होगा, -2/t³ dt होगा। सो dt/t³ क्या होगा, -dz/2z होगा, जो 1/e से cot x तक जाता है। अभी लिमिट पता नहीं है ना, लिमिट हम लोग को पता नहीं होगा क्योंकि z हमने वेरिएबल चेंज किए हैं। तो इधर से हो गया -1/2 ln z, ln z कुछ नहीं तो 1/t² + 1, और ये 1/e से cot x जा रहा है, और ये हो गया 1/2 10x पे हो गया ln sec² x प्लस माइनस, ये माइनस होगा ना, माइनस ln 1 + e²। तो ये सिंपली हो गया 1/2 2 ln sec x माइनस ln 1 + e², और इधर हो गया cot x रखने पे tan² x, जो हो गया माइनस ln 2 sec x, और ये हो गया प्लस ln 1 + e²। तो ये लगभग ये कैंसिल हो गया, ये कैंसिल हो गया, और इसका वैल्यू 0 के बराबर। तो ये 0 के बराबर आ गया, है ना। तो हम आगे बढ़ते हैं। ये क्वेश्चन इंपॉर्टेंट है ना। तो इसे हम लोग को इंटरवल पे लेते जाना पड़ेगा। जैसे अगर ये फंक्शन हो गया आई, इसको मान ले, तो 0 से लेकर 3/2 में ये निगेटिव होने वाला है, तो इसको ओपन करेंगे -2t - 3 dt से, और 3/2 2x ले तो ये 2t-3 dx होने वाला है। तो अगर 3/2 पे चेक करें, है ना, डिफरेंशिएबल एट 3/2, सो 3/2 माइनस और 3/2 प्लस ले जाते हैं ना। इसको x ही रखते हैं ना। ये है -2t dt 0 to x. X is 3/2 minus something, okay, and this is -3 dt 0 to x. So x is tending to 3/2 minus h, और ये हो गया 2t dt, dx था, इसको dt बोलते हैं ना, इंटीग्रेशन 3/2 टू x -3 dt इंटीग्रेशन 3/2 टू x। ये -t²/2, सो x² हो गया, 3x हो गया, है ना। और ये सिमिलरली t²/2 x² -9/4 -3x हो गया, x -3/2। तो इस तरह का पंगा पड़ रहा है ना। सो कंटिन्यूटी चेक किया कर जाए। अब अगर x 3/2 हो, ओके, x 3/2 हो और 3/2 प्लस हो, तो 3/2 प्लस ये 0 हो जाएगा और ये कंटिन्यूस। सो x टेंडिंग टू 3/2 माइनस, वो वैल्यू आएगा 9/4 -9/2 और 3/2 प्लस h, तो ये भी आएगा 9/4 -9/2, जो कंटिन्यूस हो गया। फॉर डिफरेंशियबिलिटी, हम लोग डिफाइन करेंगे ix, x less than 3/2, it will become 3x minus x², x bigger than 3/2. We'll define the function will come out to be -x² cancel, it is 3x. 3x minus 9/4 minus 3x plus 9/2, which is nothing but 9/4. So slope at 3/2 plus h, so I dash x, so what will happen if we will try to say I dash x, okay, it is 3 minus 2x at x equal to 3/2, which is 0, and for x bigger than 3/2 it is still 0, so it is coming out to be differentiable also. So option is coming out to be differentiable at D, differentiable at 3/2, so it is differentiable everywhere, okay. So A, B, C, D, we got the answer. So this is coming out to be simply 9/4, okay. So the slope of this one at x less than 3/2 is 0, and the slope of this one is also 0. That means it is differentiable at x equal to 3/2, continuous at x equal to 3/2, and x equal to 0. X equal to 0, it is going to be continuous and differentiable both. Yes. So this is good question for JEE mains and JEE advanced both. So if you have to check this question, So what will happen, we will have simply fx, x is 0 to pi. Okay, so when x is less than 2 pi by 3, it will open with x plus pi by 3 sine theta d theta. When x is bigger than 2 pi by 3, it will open with x2 pi sine theta d theta minus pi to x plus 2 pi by 3 sine theta d theta. Okay, we have to open functions in this way. Getting now fx is strictly increasing in the interval. Okay, so if we do, we'll find fx, which is what, minus cos x plus pi by 3 minus cos x for x less than equal to 2 pi by 3, and other function we are getting is minus cos theta, theta is x2 pi, and this is plus cos theta, theta is pi to x plus 2 pi by 3. Okay, this is minus, yes. So we'll go further. We have cos c minus cos d. Okay, cos c minus cos d is minus 2 sine x plus pi by 6 sine pi by 6. X is less than 3 by 2. Here cos pi is minus 1 if we try to simplify, and it is plus cos x, and this is cos x plus 2 pi by 3 plus 1. So we are simply getting 2 plus cos x plus 3. This is cos x plus pi by 6 cos pi by 6. When x is bigger than equal to, this is 2 pi by 3, 2 pi by 3. Okay, now range of value of fx is strictly increasing. So this is x is less than 2 pi by 3, so it's like 120 plus 30, 150. So this is negative, so fx is decreasing when this is happening. And when x is bigger than 2 pi by 3, okay, it will be increasing, like 2 pi by 3 is 120 plus 30, 150. So 150, so it is when x is less than 2 pi by 3. Okay, when x is less than 2 pi by 3, it is somewhere going to be minus of this thing, x0, 0 पे minus 1 by 2, and at x equal to 2 pi by 3, 2 pi by 3 is 150, 90 plus 60, 1 by 2. It is going somewhere like this. Okay, So the graph is like this, okay? And at 2 pi plus 3, at 2 pi plus 3 is, it is 90 plus 120 plus 30, 150, 90 plus 60, cos 90 plus 60 minus sin 30. So minus 1 by 2 into 2 minus 1 minus root 3, 2 150, 90 plus root 3 by 2 minus root 3 by 2 root 3 by 2. So it will be 1 by 2, okay? It will be 1 by 2. It will be 3 by 2. 1 by 2, okay? 1 by 2. And then if it is going to pi, at pi it is minus 1 by 2. So it is going to be somewhere like this. So it has maxima at pi by 3. X equal to pi by 3, it has maxima. We are getting some negative value. So we are getting minima, and range is from 1 to 2 minus root 3. We will have to check it, okay? Differentiable in all the interval, and this is not connecting, okay? So I think we'll have to check whether it is coming negative or positive. Okay, we'll have to check this. Okay, this you can do as a homework. हाँ रूम में रखी हाँ रूम में रखी अभी शाम को आता है So in previous question, if you see, we are not going to proceed ahead, okay? We'll just see here. X to pi by 3, we got minus cos pi. So it is sin C plus D by 2 sin D minus C. So it will come out to a minus pi by 6, which is minus minus plus. And at x equal to 0, it is going to be sin 30 1 by 4, which is 1 by 2. So this is going to be 1 by 2 1 by 2, and it is going to be connected here, okay? So in between 0 to pi by 3, we are getting pi by 3. So pi by 3 is 60 plus 90 is 1, and this is going to be max at 1, okay? This max is 1. So max is 1, we got it max as 1. And range is from 2 minus root 3. So we'll have to check this one. I think this curve is going somewhere like this. So at this point, we'll have to check the differentiation. So if you differentiate, it is something cos x plus pi by 6 at 2 pi by 3, okay? So 120 plus 120, this is 1 by 2, 1 by 2, 1, 2 gone. It is sine, and it is root 3 by 2. So it is root 3. 2 plus root 3 cos x plus pi by 6. Okay. So when it become 1, when it will become minus 1, so minus 1 is possible when it is 5 pi by 6. 5 pi by 6 is less than pi, so the minimum will go to 2 minus root 3. So minimum will be 2 minus root 3, and maximum will be 1. That we got it. So we got option D, option C. It has maxima at pi by 3. We got that at pi by 3 it is 1. So option D we got it. Option B. Now we differentiated this, we are getting cos x plus pi by 3. Add 2 pi by 3, it is 1 cos 150. So from here we are getting cos 150, and when we differentiate this one, we are getting minus root 3 sine 150. So are they same? Cos 150 is 90 plus 60. So which is minus root 3, and this is minus root 3 by 2, this is 1 by 2. So we are getting the same slope at x equal to 2 pi by 3. So it is differentiable also. So BCD is the answer. F is an odd function defined everywhere, periodic with x period 2, and integrable in the interval. Okay. So fx is odd function. So 0. So we are told that when x is 2n, okay, so it will go like 0 to 2, 2 to 4. Can we say it is n times 0 to 2 ft dt? Okay, and it is periodic. Okay, it is periodic in the sense like it is odd, like means this is this way, then this is this way, and after 2 period it is again repeating, that means this is this way, this is this way. So what will happen? 0 to 1 and 0 to 2, it is going to get cancelled. So 0 to 2 is nothing but n into 0, which is 0. So this is option A. Option B. Gx is an even function. So they are saying that gx is an even function. Okay, fx is odd function. Then gx is what? Integration part is what? So gx is going to be so if fx odd, the integration is going to be even. So we have to prove this. Okay. So if we consider this function is mm, integration 0 to 2 ft dt is 0, integration minus 1 to 1 ft dt is 0. Okay, so we have to prove that fx equal to f minus x. This is what we have to prove. We have to prove gx equal to g minus x. Okay, so integration gx is 0 to x ft dt, g minus x is 0 to minus f ft dt. Put t equal to minus t. Okay, so put t equal to minus t. This is g minus x. It will become 0. It will become x. It will become minus f minus t, and this will become minus dt. So it is nothing but minus of 0x f minus x dx. Okay, so we have to prove gx is equal to minus of 0x f minus x dx. We know that fx is equal to minus of fx. So can we say that it is minus of fx, which is nothing but gx? So g minus x came out to be gx. Yes. So gx and fx has same period. So that is true. X plus t, gx plus t will come out to be x plus t and x plus t. So it is going to have same period. So we got A, B, C as an answer. This question solved as a homework. This question I am going to take in the class. Okay. So let fx be a function fx equal to 100 by x. Fx is this 1 to x. Okay. So what will happen? We know that f1 is f100, f2 is f50, similarly f10 is f10, f9 is f100 by 9, f2, f5 is f20. So what will happen? If we have integration 1 to 10 fx by x is equal to 5, and this is dx. So in this, x is from 1 to 10. If we do 1 by x, it is 1 by 10 to 1. No, if we do 1 by x, x will become 1 to 1 by 10. Okay. The limit will become like this. Okay. Now if we multiply 100x, it is 100 to 10. Okay. Okay. So this is I. We are trying to make few changes. In place of x, we are writing 100 by x. So f 100 by x is nothing but 100 to 10. X is written by 100 by x. In place of x, we are writing 100 by x, which is nothing but minus 100 by x square dx. If you see it, it is nothing but x, this gone, this gone. We have minus of 100 to 10 f 100 by x upon x dx, and it is nothing but 10 to 100 f 100 by x upon x dx. If you go it further, we know that f 100 by x is nothing but x. So it was I, which was 1 to 10 fx by x dx, and we converted it to 10 to 100 fx by x dx. Got it? Because this is nothing but this thing. And now we have to find I1, which is 1 to 100 fx by x dx. So can we write it 1 by 10 fx by x dx? Okay, plus 10 to 100 fx by x dx, and 10 by 100 fx by x dx is nothing but 2 times of 1 to 10 fx by x dx, and this value is nothing than 5, so it's simply 10. So this is the way JEE Mains will try to make you all full. Okay, so this is from my class notes. Okay, and it is of high quality, IIT advanced level. Okay, so this is the question. I would like you to take it as a homework. This question, take it as a homework. Now we are moving to property 4, which is lecture number 3. Okay, so we are on lecture number 3. Before this, I wanted to take this question. Okay, I wanted to take this question. We will add 1 plus e to the power x. We will subtract 1 minus e to the power x. So we are getting 0 to 1 dx upon x plus 1 to e to the power x. Okay, and we have minus 0 to 1 plus e to the power x plus 1 e to the power x dx. If we consider this z, this is dz. So from here we can get ln x plus 1 e to the power x 0 to 1. Okay, and from here we have x plus 1. We'll have to make few let's check it. Okay, can we put x equal to ln x? mm, so we have to find this value. Okay, we'll take e to the power minus x common. Okay, it will become e to the power minus x, x e to the power minus x plus e to the power minus x plus 1 dx. Is it going to help us? If we keep it t, this is x e to the power minus x. If we keep t equal to x e to the power minus x plus e to the power minus x plus 1, we'll get dt equal to e to the power minus x plus minus e x e to the power minus x. This is going to be nothing but minus e to the power minus x dx. So it is simply minus x e to the power minus x dx. Okay, we got it. This is z, then this is minus dz. Okay, so see how simply we got it. Minus dz upon z, which is nothing but minus ln z x e to the power minus x plus e to the power minus x plus 1 0 to 1. At 1 it is 2 e to the power minus 1 plus 1. At 0 it is nothing but ln 2. So we are overall going to get it as 2 upon 2 plus e. So k is something like this. Okay, we got it. Now lecture 3. 1 2 3 4 5 6. Property number 4. Okay, okay, we can easily pull it. Okay, no problem. So 1 minute of break, then we'll start with property 4. Okay, so let's continue. Property number 4. So it's a time for property number 4. So property number 4 is nothing but if we are told to integrate from minus a to a fx dx, we can write it as 0 to a एफ एक्स प्लस f minus x dx. So it is correct, isn't it correct? It is correct. So when it is odd, it is going to be 0 because f minus x is minus x. It is 0 when x belongs to odd, when fx is odd, okay? And it is 2 times of fx integration 0 to a when fx is even. I think you agree with it. इफ समवन इज हैविंग सम प्रॉब्लम, किसी को हुलचुल मच रही है, तो मैं था प्रूफ दे देता हूं. ओके, प्रूफ दे देता हूं. देखो, -a टू 0 एफ एक्स डी एक्स प्लस 0 टू a एफ एक्स डी एक्स बोला जा सकता है. इस इक्वेशन को -a टू 0 0 टू a लिख सकते हैं. अब देखो, x को -x रखते हैं, तो ये क्या हो गया, f माइनस एक्स, और dx क्या हो गया, माइनस dx हो गया. ओके, हो गया. और x को -x रखे, x माइनस a से 0 था, तो -x क्या हो गया, ये a से 0 हो गया. और इधर क्या था, 0 टू a एफ एक्स डी एक्स था. तो ये माइनस इस लिमिट को इनवर्स कर देगा. दिस लिमिट विल गेट इन्वर्टेड 0 टू a f minus x, and there we have fx dx. We got the proof हमारे पास आ गया है ना, प्रूव्ड. तो क्या सर, अब क्या करें, बोले तो अब कुछ क्वेश्चन ले ले. क्वेश्चन में पहला क्वेश्चन ऐसा आ गया. ओके, तो ये क्वेश्चन तो इनवर्स का नहीं दिख रहा है, लेकिन इसको थोड़ा सॉल्व कर ले, शायद इनवर्स दिख जाए. ये cos x, ये 2 cos स्क्वायर x -1, और नीचे sin x है dx. ओके, ये तो प्रॉपर्टी 4 का क्वेश्चन नहीं दिख रहा है ना. इसको 1 माइनस 2 साइन स्क्वायर एक्स लिखते हैं, तो ये कॉट एक्स माइनस कॉस एक्स 2 साइन स्क्वायर एक्स आएगा, तो 2 साइन एक्स लग जाएगा. तो ये तो नहीं दिखा, ये सिंपली ln साइन एक्स 0 टू पाई आ गया, और ये साइन एक्स को t मानो तो ये dt हो गया. तो साइन स्क्वायर एक्स बाई 2 हो गया, 2 2 कैंसिल, 0 टू पाई, तो ये 0 हो गया. और साइन पाई पे इंफिनिटी हो रहा है, साइन पाई माइनस पे 0 प्लस एच, और साइन 0 प्लस पे 0 प्लस एच. तो दे आर गोइंग टू हैव द सेम टर्म, 0 प्लस एच, तो ये भी 0 हो गया है ना. तो ये तो वैसा क्वेश्चन नहीं दिखा है ना, ये भी वैसा क्वेश्चन नहीं दिख रहा, ये भी नहीं दिख रहा. तो प्रॉपर्टी में कुछ ओके, नहीं नहीं, वो प्रॉपर्टी में कुछ प्रॉब्लम था क्या, देखते हैं. हाँ, ये क्वेश्चन दिख रहा है उस प्रॉपर्टी से, ये क्वेश्चन दिख रहा है ना. हम्म, उस प्रॉपर्टी से ये क्वेश्चन भी नहीं है, ये क्वेश्चन भी नहीं है। तो मैं मेरा ये बोलना है क्या कि वो बेसिक प्रॉपर्टी है नॉर्मली, है ना, कि हम लोग इसको इस तरह से लिख सकते हैं। तो एक एग्जांपल ले लेते हैं ना, लेट्स टेक वन एग्जांपल, -1 to 1 x dx। तो इसको सिंपली लिख सकते हैं 0 to 1 fx जो x हो गया और f-x जो x हो गया, उसको dx कर सकते हैं, तो ये वैल्यू 0 हो गए। ये सिंपल एग्जांपल हो गए, है ना। ये सब क्वेश्चन कहाँ से आ रहा है जी, कहाँ से आ जाते हैं ये लोग। सो irrespective of those property we'll take few questions, है ना, ये क्वेश्चन सेशन लेते हैं। दिस इज 0 to pi, we'll take cos square x common, we are getting sec square x dx, and this is sec square x plus 3। अब इसको क्या करें, 0 to pi, ये sec स्क्वायर एक्स ही रहने दे और इसको 1 + tan² x रख देते हैं, जो tan² x +4। अब ये इसको t माने तो ये dt हो गया, तो dt/t² + 4 क्या होगा, t² + a², ये होता 1/a tan इनवर्स t/a विच इज tan x/2। अब ये 0 और पाई रखते हैं, 0 पे 0 पाई पे 0, तो ये 0 हो गया। tan पाई 0 tan 0 0, तो ये 0 हो गया। cot इनवर्स x होल स्क्वायर, तो इस पे इंटीग्रेशन करते हैं, तो x को cot थीटा रखते हैं, है ना, तो ये थीटा स्क्वायर हो गया और ये हो गया dx हो गया माइनस कॉसेक स्क्वायर थीटा डी थीटा, और लिमिट चेंज होंगी। जैसे x 0 था तो ये π/2 हो गया, और x जब इन्फिनिटी हो गया तो ये पाई हो गया शायद, नहीं नहीं, ये π/2 था। तो x 0 to इन्फिनिटी गया, है ना। अब हमने x को cot थीटा रखा, तो थीटा क्या हो गया, cot इनवर्स 0 से cot इनवर्स इन्फिनिटी। सो अब cot इनवर्स का ग्राफ देखे तो ये ऐसा जा रहा है, तो ये 0 से इन्फिनिटी, दैट मीन्स π/2 to 0 ऐसा जा रहा है ना। और ये हो गया माइनस थीटा स्क्वायर कॉसेक स्क्वायर थीटा डी थीटा। तो निगेटिव पे कारण ये इनवर्स हो जाएगा, 0 to π/2 हो जाएगा, और थीटा स्क्वायर कॉसेक स्क्वायर थीटा डी थीटा हो जाएगा। अब इसको कैसे सॉल्व करें गुरुजी, तो थीटा स्क्वायर को कॉमन लेते हैं, कॉसेक को कॉट करते हैं, फिर ओके इसको मल्टीपल बाय पार्ट, इट विल गो थ्रू मल्टीपल बाय पार्ट। तो पहले थीटा स्क्वायर को कॉमन लेते हैं, कॉसेक स्क्वायर का इंटीग्रेशन कॉट माइनस कॉट थीटा हो गया। अब माइनस माइनस प्लस 2 थीटा कॉट थीटा होगा, ये 0 to π/2 है ना। और ये हो गया, इसको फिर से करते हैं, ये 2 थीटा हो गया। अब कॉट थीटा को ln साइन थीटा लिखते हैं और इसका डिफरेंशिएशन करते हैं तो -2 इंटीग्रेशन ln साइन थीटा डी थीटा आएगा। ओके, अब ln साइन थीटा का इंटीग्रेशन क्या होगा? होगा इंटीग्रेशन, ओके, ये 0 to π/2 है, ये 0 to π/2 है, ये π/2 पे π²/4 ये 0 हो गया, और 0 पे लिमिट थीटा टेंडिंग टू 0 थीटा स्क्वायर है ना, कॉस थीटा तो 1 हो गया, साइन थीटा/थीटा 1 हो गया, और एक एक्स्ट्रा थीटा है तो ये 0 हो गया। π/2 पे ये 0 हो गया, 0 पे ये ln 0 0 प्लस ln इन्फिनिटी/इन्फिनिटी तो ये भी 0 ही होगा, है ना। तो हम बच गए किसके साथ? वी आर लेफ्ट विथ i इक्वल टू -2 0 to π/2 ln साइन थीटा डी थीटा। अगर इसको सॉल्व करते हैं तो हम लोग ये कर देंगे क्या, थीटा को π/2 माइनस थीटा रखेंगे, थीटा को π/2 माइनस अल्फा लिख देंगे। ओके, सो डी थीटा विल कम आउट टू बी माइनस डी अल्फा। ओके, और थीटा 0 to π/2 है, थीटा 0 to π/2 है, तो अल्फा क्या हो जाएगा? थीटा इज 0 to π/2, देन व्हाट विल हैपन, अगर मैं थीटा को π/2 माइनस अल्फा लिख देता हूं तो अल्फा क्या होगा? π/2 to 0 हो जाएगा। ओके, और फिर माइनस डी थीटा माइनस अल्फा होगा, तो ये हो जाएगा नॉर्मली -2 0 to π/2 ln cos अल्फा डी अल्फा। अब मैं ये करूंगा, ये भी आई है, ये आई है, तो इसका 2i करूंगा, तो क्या मैं ये बोल सकता हूं कि -2 0 to π/2 ln साइन थीटा, और ये अल्फा अल्फा इसको भी थीटा थीटा कर देते हैं, ln cos थीटा डी थीटा हो जाएगा। ओके, सो नॉर्मली वी हैव टू रिमेम्बर दैट ln sin थीटा इज -π/2 ln 2, तो हम उसे प्रूव कर रहे हैं ना, वी आर प्रूविंग दैट। तो ये -i हो गया, और ये 0 to π/2 ln साइन थीटा कॉस थीटा, 2 से डिवाइड करो, 2 से मल्टीप्लाई, साइन 2 थीटा माइनस ln 2 डी थीटा, है ना। अब ये क्या हो गया, 0 to π/2, आर वी एबल टू सी दिस थिंग? ओके, वी आर एबल टू सी ln साइन 2 थीटा डी थीटा of ln is simply that -π/2 ln 2, ये हो गया। अब देखो, थीटा इज 0 to π/2, है ना, तो 2 थीटा 0 to π होगा। ओके, तो ये करते हैं कि किधर दिख रहा है, इधर दिख रहा है ना, तो ये -i है, 2 थीटा को z मान लेते हैं, तो ये dz/2 हो गया, और ये 0 to π हो गया। है ना। और हमारे पास क्या है, -π/2 ln2 है। अब देखो, sin theta is symmetrical about 0 to π/2 and π/2 to π। यस, तो इसमें ये 2 टाइम्स हो जाएगा और ये कैंसिल। क्या हम बोल सकते हैं कि ये क्या हो गया, -i 0 to π/2 ln sin थीटा d थीटा -π/2 ln2 हो गया। ओके, सो वी आर कीपिंग इट अहेड। ओके, तो ये -i इक्वल टू हो गया 0 to π/2 ln sin थीटा d थीटा -π/2 ln2। और अब हम लोग इधर देखें तो 0 π/2 ln2 ये क्या है, -i/2। तो ये जो है ये कुछ नहीं, -i/2 है, और ये -π/2 ln2 है, और ये -i है। तो इसको इधर भेजें तो ये क्या होगा, -i/2 इक्वल टू -π/2 ln2। इसको सिंपली देखें तो i क्या हो गया, पाई ln2। तो अब से हम याद रखेंगे कि कि I was -2 ln sin theta d theta. So I came out to be -pi ln2. So I can say that we will remember from now, star mark, ln sin theta d theta integrating from 0 to π/2 is -π/2 ln2. Okay, this we will remember forever, and this is the proof which I did right now. Now this is this question. This is 0 to infinity ln 1 plus x square. So we'll put x equal to tan theta. So we are going to get ln sec square theta d theta upon sec square theta. This and this cancel. It is simply 2 minus 2. When x is tan theta, it is tan inverse 0 to π/2 ln cos theta d theta. Now what will happen? We know that ln sin theta d theta is -π/2, and we should be knowing that ln mod cos theta d theta 0 to π/2 is again -π/2 ln2. Okay, this also we remember. So this is the same thing. So we'll simply do -2 -π/2 ln2, which is pi ln2. Got it? Now if you remember, so note that integration 0 to π/2 ln mod sin theta d theta is equal to 0 to π/2 ln mod cos theta d theta is equal to -π/2 ln2. Remember this. Okay. Now we are going with this formula. 0 to infinity. We'll put x equal to tan theta. So limit will convert from 0 to pi by 2. This is theta upon tan theta sec square theta sec square theta d theta. This cancel. We have nothing but 0 to pi by 2 theta cos theta sin theta d theta. We'll do by part. Consider this as first function, this as second. First we'll take theta. This is cos theta upon sin theta. So take it t. This is dt. ln sin theta 0 to pi by 2 minus differentiate this one. We are going to get ln sin theta d theta 0 to pi by 2. This is I. We know that this value is nothing but minus pi by 2. So this will come out to be pi by 2 ln 2 at pi by 2. This is 0. At 0 it is minus. Now limit theta tending to 0. It is ln sin theta upon theta. Yes. So this is infinity. If we send this minus inside, it will become cosec theta. Cosec theta at 0 is infinity and sin theta 0. So this is going to be infinity. Ln sin theta. Oh, it is plus 1 minus 1. It is going to be infinity. No, no, no. We will have to check something. Okay. It is ln sin theta upon theta. If we take minus, okay, it is cosec inverse, cosec theta. So cosec theta at 0, 0 plus is infinity and theta is infinity. So infinity is infinity, infinity. Sin theta 0 plus infinity. Okay. So we are getting some infinity value. Is it so? No, 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 no. We should not be getting any infinity value. Theta sec square theta d theta. Tan theta sec square theta. At 0, this is 0, this is infinity. So theta will come out to be 1 by theta. Okay. and if you apply L hospital, it is going to be 0. Okay, theta is 1 by theta, isn't it? We wrote theta, which is wrong. Okay, moving ahead. Now this is the question. So what will happen? 0 to 1 sine pi by 2 x dx. X is 0 to 1, pi by 2 x is pi by 2 to 0, 0 to pi by 2. Okay, we'll put pi by 2 x as t. T will become 0 to pi by 2. So dx, we got t equal to pi by 2x. So dt is equal to pi by 2 dx. So dx is nothing but 2 by pi. So this is 0 to pi by 2, 2 by pi ln sin x dx. If you say dt, sin ln sin t dt. So it is 2 by pi, and 0 to pi by 2 ln sin x dx is minus pi by 2 ln 2, which is nothing but minus ln 2. Okay, these all are the question that I think you should be solving. 5, 6, we were in 6. Okay, okay, we started with 6, that is why I thought like where the other went. Okay, we started with 6. Oh, it should have started with 4. We started with 6. Okay, after this it is 4. We started with 6. Still no nothing, we solved lots of question. So property 4 is simply minus a to a fx plus f minus x is equal to 0 to a fx plus f minus x dx. It is 0 when fx is odd. It is 2 integration 0 to a fx dx when fx is even. Okay, so this is the question. So these are very basic question. Now we came to this thing. Yes, put x equal to minus x. Okay, put x equal to minus x, we are going to get 1 to minus 1, and this is minus dx. It is going to be 3 to the power minus x plus 3 to the power x, 1 plus 3 to the power minus x. It is nothing but minus 1 to 1. If you solve it, it is 3 to the power x, 3 to the power x, 3 to the power minus x upon 3 to the power x plus 1 dx. Okay, so it is I and this is I. So if we add both the I, it is I plus I is nothing but minus 1 to 1, 3 to the power x, 3 to the power x plus 3 to the power minus x upon 1 plus 3 to the power x plus 3 to the power x, 3 to the power minus x upon 1 plus 3 to the power x dx. So if you add it, it is 3 to the power x plus 1. We are going to get minus 1 to 1, 3 to the power x plus 3 to the power minus x dx, and it is 2i. Okay, Okay, and you can simply write this as minus 1 to 1 3 to the power x dx plus minus 1 to 1 3 to the power minus x dx. If you solve it further, it is 2y equal to 3 to the power x upon ln 3. Okay, minus 1 to 1, and it is 3 to the power minus x. It is minus ln 3 minus 1 to 1. So I is nothing but 1 by 2 ln 3 3 minus 3 to the power minus 1 minus 3 to the power minus 1 plus 3 to the power 1. So it is nothing but ln 3 3 minus 1 by 3 8 by 3 ln 3. Okay, moving ahead, minus pi by 2 to pi by 2. So we can get that this is even function. Can we write this as 2 times of 0 to pi by 2 cos x dx, which is nothing but 2 times of sin x 0 to pi by 2, which is 2. If we put x equal to minus x, so this is going to be what? Odd function, because minus 1 to 1 we can write simply 0 to 1 fx plus f minus x dx. And if you see, this is an odd function, so this is answer is 0. Mod x, this is even function. Yes, mod about 0, it is even function. If you see, it is somewhere like this. So this area, can we say simply twice of 0 to 1 x dx, which is x square by 2, which is 1. This question I, this is odd function, so answer is 0. This question I, we can say 0 to pi by 4 fx plus f minus x dx. Yes, so we can simply say it is 0 to pi by 4. Fx is what? Sec x 1 plus 2 to the power x plus minus x. Sec minus x is sec x. It is 1 plus 2 to the power minus x dx. This is 0 to pi by 4 sec x 1 plus 2 to the power x common. Here it is 1, and if you see here, it is 2 to the power x dx. So this and this going to be cancelled. We have simply sec x dx, which is nothing but ln sec x plus 10x, which is 0 to pi by 4. At pi by 4, sec is root 2, 10 is 1. At 0, it is exact, it is sec 0 is 1, 10 0 is 1, 10 0 is 0. So ln 1 is 0, so it's simply ln root 2 plus 1. So these are the few more basic questions if you want to revise. ओके, so first I mod x is going to be even function, so we can simply say 2 0 to 1 e to the power x dx. Okay, and integration of e to the power x is e to the power x, which is 1 minus 1. Second, minus pi by 4 to pi by 4 mod sin x is an even function, so we can say I is equal to 2 times of 0 to pi by 4 sin x dx. This is 2. Sin x is minus cos x, and it is 0 to pi by 4. So you can simply put value as 2. At pi by 4 it is minus 1 by root 2, and at 1 it is this. Third question. So see how we are using the property number 4 very easily. बहुत आसानी से प्रॉपर्टी नंबर 4 को यूज कर रहे हैं, है ना। ये माइनस पाई बाय 4 टू पाई बाय 4 है, तो आई को हम लोग लिख सकते हैं, क्या लिखे, एक्स को माइनस एक्स रखो तो ये होगा, इसको सिंपली हम लोग लिख सकते हैं 0 टू पाई बाय 4 एफ एक्स प्लस एफ माइनस एक्स होल डी एक्स। तो इसको लिख सकते हैं 0 टू पाई बाय 4 एफ एक्स हो गया एक्स प्लस पाई बाय 4 2 माइनस कॉस 2x, और f माइनस एक्स हो गया माइनस एक्स प्लस पाई बाय 4 2 माइनस कॉस 2x dx। तो x x कैंसिल, यहां से हमें क्या मिला, यहां से हमें पाई बाय 2 मिला, इंटीग्रेशन 0 टू पाई बाय 4 dx अपॉन 2 माइनस कॉस 2x। ओके, अब cos 2x का इंटीग्रेशन करना होगा, ये तो पाई बाय 2 है, सो 1 प्लस कॉस 2x को जब यहां cos 2x आता है तो हम लोग इसको हाफ एंगल में कन्वर्ट करते हैं, जो है 2 1 प्लस 1 माइनस 1 माइनस टेन स्क्वायर एक्स। 1 माइनस टेन स्क्वायर एक्स अपॉन 1 प्लस टेन स्क्वायर एक्स। ओके, तो इसको फर्दर कैसे लिखेंगे, पाई बाय 2, ये हो गया 0 टू पाई बाय 4 2 प्लस 2 टेन स्क्वायर एक्स माइनस 1 प्लस टेन स्क्वायर एक्स, और यहां सेक स्क्वायर एक्स हो गया। तो आगे बढ़ते हैं ना, स्पेस तो दिया ही है ना। इफ यू आर गोइंग फर्दर, तो टेन थीटा को टेन एक्स को टी मान लेते हैं ना, जेड टी, तो टी माने तो ये 0 टू 1 हो गया, ये डी टी हो गया, नीचे में 1 प्लस 3 टी स्क्वायर हो गया। अब 3 या इधर से कॉमन लेते हैं, डिवाइड बाय 3, डिवाइड बाय 3 मल्टीप्लाई बाय 3, तो ये कैंसिल हो गया। तो डी टी बाय टी स्क्वायर प्लस ए स्क्वायर क्या होता है, ये होता है पाई बाय 2 टेन इनवर्स टेन एक्स बाय 1 बाय रूट 3, जो रूट 3 हो गया इधर, और यहां पर अपन ये होता है 1 बाय टेन इनवर्स टी अपॉन ए, सो टेन इनवर्स टी ये हो गया और अपॉन ए, फिर यहाँ पे √3 मल्टीप्लाई हो जाएगा और ये वेरी कर रहा है 0 to 1, है ना। नहीं, जब x आ गया तो 0 to π/4 वेरी करेगा, है ना। तो ये हो गया √3 π/2। जब π/4 हो जाए तो टेन इनवर्स √3 क्या हो गया, π/3, और जीरो पे जीरो हो गया, तो ये हो गया π²/2√3। ये आंसर हो गया। तो ये थर्ड का हो गया। फोर्थ को सॉल्व करते हैं। तो फोर्थ ये होगा कि ये इवन है, ये ऑड होगा, तो ओवरऑल वैल्यू 0 हो गया। फोर्थ का वैल्यू -1 to 1 था, साइन 5x cos 4x dx। तो दिस इज ऑड and this is even, so overall we are odd, so in odd we got that integration is 0। फिफ्थ वन ये वाला फंक्शन हो गया। तो अगर हम लोग आई लेते हैं -π/2 to π/2, it is gx minus of g minus x upon fx plus f minus x dx। तो इसको हम लोग सिंपली लिख सकते हैं 0 to π/2 gx minus g minus x upon fx plus f minus x plus of g minus x minus of gx upon f minus x plus fx dx। तो ये इससे कैंसिल हो गया, ये इससे कैंसिल हो गया, ये 0 के बराबर हो गया। तो अब इस पर आते हैं, है ना। दिस इज बेसिक कंसेप्ट टेकन फ्रॉम इनवर्स ट्रिग्नोमेट्रिक फंक्शन, है ना। तो साइन इनवर्स एक्स कॉस इनवर्स वाई, वो साइन इनवर्स एक्स आई, साइन इनवर्स ये होगा, तो नॉर्मली क्या, ये सम अगर ओपन होगा तो साइन इनवर्स एक्स आई, साइन इनवर्स x2, साइन इनवर्स x3, साइन इनवर्स x4 प्लस कॉस इनवर्स x1, कॉस इनवर्स x2, कॉस इनवर्स x3, कॉस इनवर्स x4। ये दिया है 6π के बराबर, है ना। तो साइन इनवर्स का मैक्सिमम वैल्यू π/2 होता है। तो π/2 अगर हम मैक्स लेते हैं तो 4 इंटू π/2, और कॉस इनवर्स का मैक्स वैल्यू पाई होता है, तो 4π। तो ये जाकर 6π हो रहा है। दैट मीन्स साइन इनवर्स xi is equal to π/2 and cos inverse xi is equal to π। तो x1 का वैल्यू क्या, ये yi होगा, ये कोई दूसरा है ना, yi। तो x1 xi का वैल्यू 1 होगा, yi का वैल्यू -1 होगा, क्योंकि cos बोथ द साइड्स लेंगे। तो अब इधर बोल रहा है समेशन ऑफ xi, समेशन ऑफ xi क्या हो गया, 1 2 3 4। तो ये सिंपली हो गया -+4 से -4, और ये हो गया x ln 1 + x² e टू द पावर x 1 प्लस ई टू द पावर 2x dx। अब देखना है कि इसका सम अगर माइनस ए से ए हो तो x को माइनस एक्स रखो तो ये पॉजिटिव होगा, ये इवन ही होगा, ये इवन हो गया। x को माइनस एक्स रखने पे ये आएगा e टू द पावर माइनस एक्स 1 प्लस ई टू द पावर माइनस 2x। जिसको फर्दर सॉल्व करेंगे तो ये e टू द पावर x 1 प्लस ई टू द पावर 2x ही आ रहा है, मतलब ये भी इवन हो गया। बट ये ऑड होगा, तो ये इवन ये इवन ये ऑड, दैट मीन्स द वैल्यू इज गोइंग टू बी ऑड विच इज इक्वल टू 0। आ गया समझ में? आई थिंक यू ऑल गॉट इट। अब हम लोग प्रॉपर्टी नंबर 5 पे चलते हैं, है ना। प्रॉपर्टी नंबर 5 पे चलते हैं। फिर प्रॉपर्टी नंबर 6 पे चलेंगे। तो प्रॉपर्टी नंबर 5 बहुत ही क्रेजी प्रॉपर्टी है, इस पे आईआईटी एडवांस पे क्वेश्चन आते हैं, है ना। So you get question in IIT advanced, है ना। So property 5 is saying that if we are doing a to b fx dx, it is equal to a to b f a plus b minus x dx। ये इतना ही है, इसका प्रूफ चाहिए। हम लोग देखते हैं कि x a से b है, माइनस एक्स माइनस ए से माइनस बी है, ए प्लस बी माइनस एक्स, ए इसमें ए प्लस बी ऐड किया, बी से ए है ना। तो ये होगा कि ए टू बी एफ एक्स डी एक्स में अगर एफ ए प्लस बी माइनस एक्स रख दे तो ये z हो गया, ये z हो गया, तो dz क्या होगा, माइनस dz हो जाएगा और हमारा लिमिट b टू a हो जाएगा। और ये जब माइनस जाएगा तो कैन वी से दैट इट इज a टू b f a प्लस b माइनस x dx। ओके, आई थिंक यू गॉट द प्रूफ। अगर दिमाग में कुछ ना आए तो ये फॉर्मूला यूज करो, a प्लस बी माइनस एक्स डी एक्स कर लो, ये इंपॉर्टेंट हो जाता है। एक एग्जांपल लेते हैं, ये i है ना। तो i में पाई बाई 2 प्लस 0 माइनस एक्स करते हैं, तो ये हो गया g साइन पाई बाई 2 प्लस 0, जो पाई बाई 2 माइनस एक्स हो गया, और ये हो गया g साइन पाई बाई 2 माइनस एक्स प्लस g कॉस, g के अंदर कॉस पाई बाई 2 माइनस एक्स, और ये dx हो गया। इसको फर्दर देखें तो ये 0 to π/2 जी cos x जी cos x प्लस जी साइन एक्स dx हो गया। तो क्या ये बोल सकते हैं ये बराबर ये हो गया, और अब इसका वैल्यू निकालना है ना। तो देखो ये भी आई है, ये भी आई है, दोनों का ऐड करते हैं तो ये क्या हो गया 0 to π/2 जी साइन एक्स प्लस जी कॉस एक्स अपॉन जी साइन एक्स प्लस जी कॉस एक्स dx। तो ये सब तो कैंसिल हो गए, तो dx क्या बच गया x जो π/2 हो गया। क्या हम बोल सकते हैं क्या 2i इज इक्वल टू π/2, तो i π/4 हो गया। मूविंग अहेड, ये सब बेसिक बेसिक क्वेश्चंस हैं, है ना, जो हमें बहुत अच्छे तरीके से करने हैं। अगर इसको हम आई मानते हैं 0 to π x 1 प्लस साइन एक्स dx, तो इसको हम लोग लिख सकते हैं 0 प्लस पाई माइनस एक्स अपॉन 1 प्लस 0 प्लस पाई minus x, they are the same. Can we write this as 0 to pi minus x 1 plus sin x dx? So this is I and this is the I. अगर दोनों को ऐड करते हैं तो 2i will be 0 to x upon, this is also x, okay, 1 x upon 1 side 1 plus sin x plus pi minus x upon 1 plus sin x, okay, that is dx। अब ये क्या हो गया 2i इज इक्वल टू 0 to पाई 1 प्लस साइन एक्स dx, है ना। तो अब ये होगा कि 2i/पाई लिखेंगे, इसको हाफ एंगल में ब्रेक करेंगे, ये 0 to पाई जाएगा, ये dx हो गया, ये 2 tan x/2 1 प्लस tan स्क्वायर x/2, ये 1 प्लस हो गया। तो फर्दर सॉल्व करेंगे तो 0 to सेक स्क्वायर x/2 dx, और ये हो गया 1 प्लस tan स्क्वायर x/2 प्लस 2 tan x/2। तो ये देखो तो tan x/2 प्लस 1 होल स्क्वायर हो गया, है ना। फर्दर गोइंग अहेड ये हो गया 0 to सेक स्क्वायर x/2 dx, ये हो गया 1 प्लस tan x/2 होल स्क्वायर। तो इसको z मानो तो ये dz/2 होना पड़ेगा, है ना। तो इसको फर्दर देखो तो 2i/पाई ये z है, तो ये 2dz होगा, 2z अपॉन z स्क्वायर, जो कुछ नहीं -2/z 1 प्लस tan x/2, और ये हो रहा है 0 to पाई के बीच में टेन पाई बाय टू इन्फिनिटी जाएगा तो ये जीरो होगा, टेन जीरो पे ये वन होगा, टेन जीरो पे ये जीरो होगा तो ये टू होगा। तो टेन पाई बाय टू पे ये जीरो हो गया और टेन जीरो पे ये टू हो गया और ये टू आई बाई पाई है। सो आई नॉर्मली पाई हो गया, है ना। क्वेश्चन टू के लिए हम लोग देखते हैं। क्वेश्चन टू, दिस इज क्वेश्चन वन। तो हम लोग अगर आई देखें तो जीरो टू पाई बाय टू एक्स साइन एक्स प्लस कॉस एक्स डी एक्स हो गया, और आई को पाई बाय टू प्लस जीरो माइनस एक्स रखे तो ये साइन पाई बाय टू माइनस एक्स कॉस एक्स हो गया, कॉस पाई बाय टू माइनस एक्स साइन एक्स हो गया। अब ये भी आई हुआ, ये भी आई हुआ, दोनों को जोड़ दें तो ये पाई बाय टू जीरो टू पाई बाय टू डी एक्स साइन एक्स प्लस कॉस एक्स हुआ। अब इसका इंटीग्रेशन क्या होता है, साइन एक्स प्लस कॉस एक्स को दोनों को हाफ एंगल में ब्रेक करो और फिर इंटीग्रेशन कर लो। वी कैन डू इंटीग्रेशन फ्रॉम दिस, we'll do this in half angle, this and half angle, and we can solve it normally. I am helping you. ये नॉर्मली जीरो टू पाई बाय टू हो गया। ओके, तो ये डिलीट नहीं हो रहा है तो हम लोग फिर से इसी के ऊपर लिखते हैं। तो ये वन टू टेन एक्स बाय टू होगा, ये वन माइनस टेन स्क्वायर एक्स होगा, तो ओवरऑल सेक स्क्वायर एक्स बाय टू डी एक्स होगा और अंत में बचेगा टू टेन एक्स बाय टू वन, है ना। तो ये होगा टू टेन एक्स बाय टू वन माइनस टेन स्क्वायर एक्स बाय टू। इसको हो क्वाड्रेटिक में कन्वर्ट करो, इसको डी टी और इसको टी डी जेड लेके सॉल्व करना पड़ेगा। पहले इस क्वेश्चन को सिंपली कर देते हैं, है ना। आई इक्वल टू फाइव पाई बाय ट्वेल्व प्लस पाई बाय ट्वेल्व इज नथिंग बट इट्स अ पाई बाय टू, है ना। तो ये पाई बाय ट्वेल्व, ये फाइव पाई बाय ट्वेल्व, ये dx हो गया। तो ये दोनों का सम कितना हो गया, पाई बाय टू पाई बाय टू। तो ये सिंपली वन प्लस रूट अंडर कॉट पाई बाय टू माइनस एक्स हो गया। इसको फर्दर सॉल्व करें तो पाई बाय ट्वेल्व, फाइव पाई बाय ट्वेल्व, ये टेन एक्स हो गया, है ना। और अगर इसको देखो तो ये है पाई बाय ट्वेल्व, ये भी आई है, से फाइव पाई बाय ट्वेल्व, इसको टेन एक्स में कन्वर्ट करें तो रूट टेन एक्स डी एक्स वन प्लस रूट टेन एक्स, है ना। ये भी आई है, ये भी आई है, दोनों को ऐड कर दे तो टू आई होगा। ये पाई बाय ट्वेल्व, फाइव पाई बाय ट्वेल्व, वन प्लस रूट टेन एक्स, वन प्लस रूट टेन एक्स कैंसिल होके वन डी एक्स हो जाएगा, जो कुछ नहीं, फाइव पाई बाय ट्वेल्व माइनस पाई बाय ट्वेल्व, फोर पाई बाय ट्वेल्व, जो पाई बाय थ्री हो गया। तो इससे हमें आई इक्वल टू पाई बाय सिक्स आ गया। इधर चलें, सो आई के जगह पाई बाय टू माइनस एक्स रखें तो ये पाई बाय टू माइनस एक्स हो गया। साइन पाई बाय टू माइनस एक्स कॉस एक्स हो गया, कॉस पाई बाय टू माइनस एक्स साइन एक्स हो गया, और बॉटम में साइन पाई बाय टू माइनस एक्स होल फोर कॉस फोर एक्स हो गया, ये साइन टू द पावर फोर एक्स हो गया, ये भी आई, ये भी आई, दोनों को ऐड कर दे तो ये 0 to π/2 ऐड हो जाने पे ये पार्ट और ये पार्ट कैंसिल हो जाएगा, ये सिंपली π/2 साइन एक्स कॉस एक्स dx हो गया अपॉन कॉस टू द पावर फोर प्लस साइन टू द पावर फोर एक्स। अब ये है कि इसको t और इसको dt में कन्वर्ट करना है। So what can we do is that simply इसको 0 to π/2 को इधर ले आओ, ये 4i/π हो गया, है ना। बॉटम वाले को cos स्क्वायर एक्स होल स्क्वायर साइन स्क्वायर एक्स होल स्क्वायर प्लस 2 साइन स्क्वायर एक्स कॉस स्क्वायर एक्स माइनस 2 साइन स्क्वायर एक्स कॉस स्क्वायर एक्स लिख सकते हैं, ये dx है, ये साइन एक्स कॉस एक्स। अब ये देखो ए स्क्वायर प्लस बी स्क्वायर हो गया ये सारा टर्म, और ये क्या है कॉस स्क्वायर एक्स प्लस साइन स्क्वायर एक्स होल स्क्वायर, तो ये साइन एक्स कॉस एक्स dx और नीचे में हो गया कॉस स्क्वायर एक्स प्लस साइन स्क्वायर एक्स होल स्क्वायर माइनस 2 साइन स्क्वायर एक्स कॉस स्क्वायर एक्स। ओके, हमें साइन एक्स इंटू कॉस एक्स में के फॉर्म में लाना है। ओके, तो हम लोग इतना ना भी करके ओके हम लोग इतना ना भी करके अगर हम लोग ये करते, हम लोग इतना ना भी करके हम लोग ये करते तो क्या होता है ना, हम लोग ये ना करके है ना, इतना ना करके this is not getting deleted, okay, it should be getting deleted, okay, okay, this is not getting deleted, will divide by cos to the power 4 in up and down, it is 0 π/2 cos to the power 4, so it is 10x cos cancel sec square x dx 1 plus 10 to the power 4। ओके, इसको माइनस करते हैं और फिर डिलीट करते हैं ना, अब डिलीट हो रहा है ना, so the word which we wrote on the top they are not getting deleted। okay, no problem। so इसको अगर t मान लेते हैं, इसको t स्क्वायर मान लेते हैं, tan square x equal to z, then dz is what? 2 tan x sec square x dx. So tan x sec square x क्या dz by 2. We can simply say that it is nothing but 0 to pi by 2 dz by 2 1 plus z squared dz 1 plus z square. Yes, it is nothing but tan inverse z by 2. Tan inverse z is what? Tan square x whole divided by 2. It is 0 to pi by 2. So at pi by 2 tan x is infinity, so it will come out to be pi by 4. So I is nothing but pi square by 16. Okay, got it? So these are a few more basic questions you can say by eyes. So if you see, if you do pi by 2 minus x, the bottom is same, up is root sin x, and in other it will become root cos x. If we add, it is going to be 1. So first one is pi by 4, second one is pi by 4, third one is in place of x we put a minus x. So third one is a by 2. Fourth one will check. So fourth one will start checking I 0 to pi by 2. Okay. Now in place of sin x we are doing, it will become cos x, it will become sin x, it will become cos x, it will become sin x. So it is a cos x plus b sin x upon sin x plus cos x. This is dx. We'll add one more I. It will become 2i. So one is this I, one is this I. If we add, it is 0 to pi by 2. A plus b sin x plus cos x upon sin x plus cos x dx. So this is going to get cancelled. So dx will be x and then I will come out to be a plus b pi by 4. Okay. Fifth one. So in place of x we are putting pi by 2 minus x. So we are going to get cos x minus sin x, and at the bottom sin x plus cos x whole square dx. We'll add this I with this I. I think sin x is going to get cancelled cos x. So I is equal to 0. Okay. This is the question we are going to solve. Ln lambda. So this is I. F x square by 4 fx minus f minus x g x square by 4 gx plus g minus x dx. So if you see, it is nothing but minus ln lambda. So if you add both of them, we are going to get 0. So 0 minus x. So what we are trying to do is that it is ln lambda, this is minus ln lambda. We'll add both of them and we'll put here. So it is a plus b minus x, which is 0 minus x. So it is what? Minus x squared by 4, and this is f minus x minus fx upon g x squared by 4 g minus x plus gx dx. Now when we add this function with this function, you will get see that fx and this fx is going to get cancelled, and this is going to cancel with this one. So overall I is 0. So this question we are going to solve. So you can see that on property number 5 we have various type of examples. Okay. So in this question you see that fa is e to the power a 1 plus e to the power a. F minus a is e to the power minus a 1 plus e to the power minus a, which is nothing but 1 upon e to the power a plus 1. If you add fa plus f minus a, it is nothing but a. So now in integration f minus a to f a x gx 1 minus x dx is there. Now in place of x, can we put it as this plus this minus x, which is nothing but we can write fa plus f minus a minus x in place of x. So we'll do the same thing. So it is fa plus f minus a minus x, which is what? 1 minus x. So in this also we'll have 1 minus x, and in this we'll have 1 minus x dx. If you see, it is nothing but f minus a fa 1 minus x g x into 1 minus x dx. Now if you see, this is what? I1. This is I1. If you see, it is fa g x 1 minus x dx minus f minus a fa x g x 1 minus x dx. Can we say that this is I1 itself? So from here if you see, we are getting what? We are getting I1 is equal to I2 minus I1. If you see further, it is 2I1 equal to I2. Can we say I2 upon I1 is equal to 2? Got it? So this question, I would like to carry this question. You are looking that x is between 0 to pi square by 4. Can we say that root x is between pi by 2, 0 to pi by 2? Yes. Okay, okay, okay. Okay. In this question, we will have to solve, use some of our mind. So if we put t equal to root x, dt will be 1 by 2 root x dx. Okay. So can we say that x is equal to 2 root x? Root x is t, 2t dt. Okay. Now x is t square. So we got that root x. Okay, we are putting root x as t. So we got that t is from 0 to pi by 2. So this is 2t dt 1 plus sin t cos t. Okay, we'll keep it as I and we'll proceed further. Now in place of, so this is 2, we'll divide I by 2, we'll get integration 0 to pi by 2 t dt 1 plus sin t plus cos t. Now we'll do, in place of t we'll write pi by 2 minus t. So I by 2 is 0 to pi by 2 minus t dt, and it is 1 plus sin pi by 2 minus t is cos t, and this is sin t. So this is I by 2, this is I by 2. We'll add both of them. So we'll get I equal to pi by 2, 0 to pi by 2 dt 1 plus cos t sin t. So how to solve this type of question? We'll have again 2 pi by I. Okay, we'll convert this into half angle. So we have I 2I by pi is equal to 0 to pi by 2. If we convert it into half angle, we have simply 1 minus tan square t by 2, 1 plus tan square t by 2, and we have here 2 tan t by 2, 1 plus tan square t by 2, and here we have 1, and here we have dt. Moving further, we have 2I by pi 0 to pi by 2 sec square t by 2 dt upon, here we will have 1 plus tan square t by 2. So 1 1 2 tan square cancel, it is 2 plus 2 tan t by 2. So what will happen, we'll take 2 common, it is 1 by 2 sec square t by 2 dt upon 1 plus tan t by 2. Okay, we have this integration 0 to pi by 2. So if we put it z, this is dz. Okay, so this is nothing but ln z, which is ln 1 plus tan t by 2 0 to pi by 2. So at pi by 2 it is 10 pi by 4. So it's a pi by 4. So ln 2 into pi by 2. Okay, this is I. Got it? In this type of question, how to solve it? Okay, how to solve it? We have I. Can we write pi plus 0 minus x. Root under 1 plus cos pi minus x is cos x only, mod. If it is mod, we'll add this I and this I. We'll get 2i equal to pi times 0 to pi 1 plus 1 plus mod cos x dx. Now, can we say it further? 2i by pi, and cos x is positive from 0 to pi by 2. So it will open with 1 plus cos x, and it is negative from pi by 2 to pi. So it will open with 1 minus cos x dx. So 0 to pi by 2, 1 plus cos x is nothing but root 2 cos x by 2 dx. And from pi by 2 to pi, it is root 2 sine x by 2 dx, because it is one half angle. 1 minus cos x is 2 sine square x by 2. If you take root, it will come out to be like this. Okay, so root 2 is here. Cos x by 2 will be sine x by 2 divided by 1 by 2, which is 2, and it is from 0 to pi by 4, and this is minus 2 root 2 cos x by 2 pi by 2 to pi. Normally, going further, we have 2i by pi 2 root 2 cos pi by 4. It's a cos pi by 2. Okay, cos pi sine x is pi by 2. We'll get sine pi by 4, which is 1 by root 2, and we have 2 root 2 cos pi by 2 will become 0, and minus cos pi by 2 by 2 cos pi by 4, which is 1 by root 2. If you see, it is nothing but 2i by pi equal to 4. So I is nothing but 2 pi. So these are the few tricks which you should be using to solve multiple question. Okay, so this is the one of the again great question. So what will happen, how to solve such type of question is one of our doubts. So we'll go A1 using by part. We'll consider this as first function, like 0 to x, 0 to u, ft dt and whole dt. We'll consider this as first function, second function, and 1 as first function. So we'll go by part. First we'll take 0 to u, ft dt as second function, and we'll integrate 1 dt 0 to x, and then again 0, this is t, so it will come out to be x, and differentiate this one will come out to be fu, and we have du. Okay, it is going with respect to du. We took dt, it's not dt, it will become fu, this will become du, this is du. Okay, so this is u. Okay, got it? So it is nothing but x integration. It will go from 0 to x. At 0 it is 0, otherwise it is integration 0 to u, 0 to x ft dt. So this was the second term which came here. So it has limit from 0 to x. The first term was 1 into du. This is du, okay? The limit was from 0 to x. So du was u. So it is x minus 0, which is x. And at 0 it was 0. At x it is x. And here now we came again, it is 0 to x. Okay. Okay. This is 0 to x. U f u du. Now we'll consider this as 1. In 1, we are applying a plus b minus x. This is 0 to x. A plus b, that means 0 plus x minus u. Can we say it is x minus u? And it is f x minus u du. Okay. Okay, got it. Can we say it further? It is x 0 to x f x minus u du, and this is minus 0 to x x minus u f x minus u du. Yes. Can we say this? No, no. We got, it was x. This will come out to be u, isn't it? Yes. This will come out to be u. Now, if you see in this, if you put in place of u, we put x plus 0 minus u. Can we say it is 0 to x x minus u f. In place of u, we are putting x minus u f u du. Can we say this? Okay. And can we say this as x 0 to x f x minus u du? Now, if you put this all in this, okay, we are going to get a1 equal to x 0 to x ft dt, and in place of I will put this. Now it's what? Minus x 0 to x f x minus u du plus 0 to x, it is u, okay, it is x minus u, okay, x minus u fu du. Now in place of u, if you put x plus x minus u, it is going to be fx only. That means this and this going to be cancelled, and we can see that this is a1 and this is nothing but it is a2. So can we say that a1 by a2 equal to 1? That's all. This question, solve it as a homework. This question, solve it as a homework. This question, do you want to solve it as a homework? You can solve it as a homework. You can solve it as a homework, okay? This question, solve it as a homework. This question, solve it as a homework. Or I wanted to take this question, okay? I am taking this question. 0 to pi by 2 is fx f pi by 2 minus x dx. Okay, it is nothing but 0 to pi by 2 fx is sin x by x, f pi by 2 minus x is what? Cos x by pi by 2 minus x dx. Now what will happen? Hmm, what will happen is that we'll multiply 2 divide 2. We'll get 0 to pi by 2 sine 2x x pi minus 2x. Okay. So what can we further do is that pi by 2 minus 2x. Okay. We'll multiply 2 and divide 2. So we have 2. We are trying to make it in fragment. 2x plus pi minus 2x into sine 2x. And we are the resultant of this is pi, so multiplied and divided with pi. And we have 2x pi minus 2x. Okay. Dx integration 0 to pi by 2. Further moving I1, we have 2 by pi. We could get it as 0 to pi by 2 sine 2x by pi minus 2x plus 0 to pi by 2. We have dx sine 2x upon 2x dx. Okay. So can we say that it is pi by 2 I1? And now we'll put in place of x, can we put pi by 2 minus x? So it will come out to be sine 2x upon 2x only, and it is also sine 2x plus 2x, so it will come 2 times of this 0 to pi by 2. Now what will happen? In place of 2x we'll put z, so dz will come out to be 2x 2 dx. So this is sine z, z, and x is between 0 to pi by 2, 2x will be between 0 to pi. So can we say that I1 is I1 into pi by 2 is equal to 0 to pi fx dx. So this is what? K. So k equal to nothing but pi by 2. I think you got the answer. Okay, okay. So what we happened? We considered this property 4 and we solved here. Okay, okay. So this is property 6. So we have solved few question of property 6 already. Property 7 is periodic. Okay. So for property 6 we'll go with this. We are taking 1 second of break. Okay, 1 minute of break. Property 6 is get ready to solve multiple questions. Okay. Okay, so we are now on property number 6, which is lecture number 4. Okay, so property number 6 is what? If we are integrating from 0 to 2a, fx dx, okay, we can write it like 0 to a fx dx plus 0 to a f 2a minus x dx. Okay, so in this we can simply say that when fx is, it is 0 when fx is equal to minus of fx minus 2a, and this is 2 times of 0 to a fx dx when fx is equal to f x minus 2a. Okay, okay boss. बट कुछ स्टूडेंट को इनके प्रूफ चाहिए होंगे, है ना? हाय ऋषि, है ना? हाय ऋषि, वेलकम। तो इसके प्रूफ चाहिए होंगे। तो प्रूफ करते हैं। 0 to a fx dx प्लस a to 2a fx dx, इनको ऐसा लिखा जा सकता है। तो ये तो हमारे आ गए, अब इनको क्या किया जाए? तो अगर x के जगह पे -2a(x) लिखा जाए, देखो x a to 2a वेरी करता है, -x -a से -2a वेरी करेगा, 2a माइनस एक्स 0 a से 0 वेरी करेगा। और अगर ये z हो गया तो dz माइनस dx हो गया। ओके, तो हम ये मान सकते हैं क्या कि इंटीग्रेशन 0a to 2a fx dx में अगर x के जगह 2a माइनस एक्स रखते हैं तो x की जगह z रखे तो हमारा dx क्या हो गया? माइनस dz, माइनस dz। ओके, ये z है ना? और लिमिट हो गया a टू 0, तो माइनस आया तो ये 0 टू a f 2a माइनस एक्स dx हो गया। ये dz हो गया, ये z है ना, ये z, और z क्या है? 2a माइनस एक्स है। ये नॉर्मली क्या है? ये नॉर्मली है 0 टू a एफ जेड डी जेड, है ना? So we can simply say that it is 2a minus x dx. Okay, तो ये है नॉर्मल ऑप्शन। तो यहाँ पे हम लोग ये सॉल्व कर रहे थे, ये हमने सॉल्व कर लिया था, है ना, ये हमने सॉल्व कर लिया था, ये सॉल्व कर लिया था, ये सॉल्व कर लिया था, ये सॉल्व कर लिया था। अब इस पे आते हैं ना। ये आई हो गया 0 to π/2 टू एल एन साइन एक्स, ओके, माइनस 0 to π/2 एल एन साइन 2x dx, है ना। तो स्टैंडर्ड फॉर्मूला एल एन साइन एक्स का क्या होता है, -π/2 ln2, जो -π ln2 हो गया, और ये माइनस है। अब साइन 2x को z रखते हैं ना, तो ये हो जाएगा ln साइन z, तो dx हो जाएगा dz/2, और x 0 to π/2 था, उसको 2 से मल्टीप्लाई किया, तो ये 0 to π हो गया। और साइन, अगर तुम देखो साइन का ग्राफ, तो ये ऐसा जाता है, तो इसको हम लोग π/2 पे कर दे तो 2 टाइम्स ऑफ 0 to π/2 हो जाएगा। तो ये 0 to π/2 में 2 टाइम्स आ गया, और यहाँ एल एन साइन जेड को x रख दो, अब dx/2, और यहाँ पे क्या था, -π ln2, तो ये -π ln2 हो गया, ये दो दो कैंसिल। ln sin x dx क्या होता है, -π/2 ln2, और माइनस माइनस प्लस हो गया, तो ये सिंपली -π/2 ln2 हो गया, है ना। तो अब ये फोर्थ, x को tan थीटा रखते हैं, तो x 0 से इंफिनिटी जा रहा है, तो थीटा 0 to π/2 हो गया, और ये हो गया ln साइन थीटा कॉस थीटा प्लस कॉस थीटा साइन थीटा, और यहाँ dx हो गया सेक स्क्वायर थीटा डी थीटा, और 1 + tan² थीटा क्या हो गया, सेक स्क्वायर थीटा। ये कैंसिल, इसको आई रख लेते हैं, आई बोल देते हैं। ये 0 to π/2 हो गया, इसको एलसीएम लो तो साइन स्क्वायर प्लस कॉस स्क्वायर 1, ये साइन कॉस 2 से मल्टीप्लाई 2 से डिवाइड, ये माइनस ln साइन 2 थीटा प्लस ln2 डी थीटा हो गया। अब हम लोगों ने यहां पे निकाला था -ln साइन 2 थीटा, है ना, 0 to π/2 में था, 0 to π/2 में, तो इसके वैल्यू आए थे π/2 ln2, तो हम लोग इसको सिंपली लिख देंगे π/2 ln2, और ln2 डी थीटा हो गया π/2 ln2, जो हो गया पाई ln2। तो दोनों के वैल्यू लगभग सेम नहीं आए हैं, है ना, सेम मतलब सिमिलर टाइप क्वेश्चन थे, है ना। मूविंग अहेड, ये अब सिंपल टाइप के क्वेश्चन आने लगे हैं। अब फ्रैक्शन x 0 to ग्रेटेस्ट इंटीजर x, तो ये y हो गया, ये x हो गया, फ्रैक्शन x का ग्राफ ये होता है, तो 0 है, और ग्रेटेस्ट इंटीजर ऑफ x क्या होगा, कोई इंटीजर होगा, ओके, तो वो कुछ इंटीजर i होगा, ये इंटीजर होगा, ओके, इंटीजर i तो हमारा इंटीग्रेशन का वैल्यू है ना। तो ये हम मान सकते हैं कि अगर इंटीजर आई हो गया तो हम लोग ग्रेटेस्ट इंटीजर एक्स को उतार लेते हैं और ये 0 to 1 फ्रैक्शनल एक्स डीएक्स कर सकते हैं, क्योंकि 0 to 1 और 0 to ग्रेटेस्ट इंटीजर एक्स मतलब ये ग्रेटेस्ट इंटीजर एक्स टाइम मल्टीप्लाई होगा। और 0 to 1 का एरिया क्या होता है, 1/2 हाफ बेस, दिस इज 1, दिस इज 1 हाफ बेस इंटू हाइट। तो ये क्या हो गया, ग्रेटेस्ट इंटीजर x/2। सिंपल आंसर। ये क्वेश्चन हो गया। इसको हम लोग नॉर्मली लिखते हैं, अगर हम लोग रिवाइज करें तो 0 to 1 एफ एक्स प्लस एफ माइनस एक्स डी एक्स, ऐसा लिखते हैं। और ये 0 to 1 हो गया। एफ एक्स क्या हो गया, कॉट इनवर्स एक्स प्लस एक्स क्यूब 1 + x⁴। और एफ माइनस एक्स क्या हो गया, कॉट इनवर्स -x - x³ 1 + x⁴ होल dx हो गया। तो इधर से माइनस आएगा तो कॉट इनवर्स माइनस एक्स क्या होता है, पाई माइनस कॉट इनवर्स x + x³ 1 + x⁴ ये हो गया। और यहाँ dx हो गया, इधर कॉट इनवर्स x + x³ 1 + x⁴ ये हो गया। इंटीग्रेशन 0 to 1। तो तुम देखो कि ये और ये कैंसिल हो गया, तो हमें सिर्फ नॉर्मली पाई बच गया है ना, पाई dx। और dx क्या हो गया, x जो 1 हो गया। तो i का वैल्यू क्या हो गया, पाई हो गया ना। इस तरह के क्वेश्चन को हम लोग केसेस में ब्रेक करेंगे। सो आई ये मान ले कि ये 0 to 2 पाई है, ये मॉड √15 sin x प्लस cos x dx है। इसको हम लोग अगर देखें तो a sin x प्लस माइनस b cos x को हम लोग क्या करते हैं, नॉर्मली √a² प्लस b² √a² प्लस b² से डिवाइड और फिर मल्टीप्लाई करते हैं। तो ये क्या आ जाता है, इट कम्स आउट टू बी इन अ ट्रायंगल वी गेट दैट इफ इट इज अल्फा, ये a हो गया, ये b हो गया, तो ये √a² प्लस b² हो जाता है। सो कैन वी से दैट दिस इज sin alpha, this is cos alpha. So similarly in this question 0 to 2 pi we will divide with a² plus b² which is nothing but 4. So multiply with 4, divide with 4. This is 4, we'll consider this as, this is x, okay. We will consider this as sin alpha and cos alpha. Can we say it is 0 to 2 pi mod cos x minus alpha dx, where alpha is sin inverse √15/4, okay. Now this is it. अब x 0 से 2 पाई है, x 0 से 2 पाई है, एक्स माइनस अल्फा से 2 पाई माइनस अल्फा होगा। और एक्स को जेड मान ले तो डी जेड डी एक्स हो गया। डी जेड इक्वल टू डी एक्स, जो 2 पाई से 2 पाई माइनस अल्फा हो गया। तो इस चीज को आगे कैरी करते हैं ना, दिस इज आई। तो आई इक्वल टू 4 0 to 2 पाई। तो z हो गया, तो ये माइनस अल्फा से 2 पाई माइनस अल्फा हो गया है ना। और ये मॉड कॉस जेड डी जेड हो गया। तो अब कॉस जेड का ग्राफ देखते हैं। अल्फा इधर हो गया, ऐसा जा रहा है, ऐसा जा रहा है। तो पाई/2, ये पाई हो गया है ना, हमें 2 पाई तक जाना है। ओके। तो अगर हम देखें कि इसका लेफ्ट ओवर पार्ट ये पार्ट होगा, if we add transparent this, okay, so we can say that it is nothing but 4 0 to 2 पाई cos z dz। or now this is double time, so we can say that it is 1 2 3 4, so it is 16 times 0 to pi/2 cos z dz, and it is nothing but 16, cos z is sin z, sin pi/2 is 1, it is 16। तो what will happen, it got shifted now, okay। तो ये जो बचा हुआ पार्ट है ये इस पार्ट के बराबर होगा। तो ये इसको अगर इधर डालते हैं तो ये दो हो जाएगा, और ये दो नहीं, 1 2 3 4 हो गया। तो 0 to pi/2 में 4 टाइम्स हो जाएगा, तो आई का वैल्यू 16 होगा, है ना। दिस क्वेश्चन दिस क्वेश्चन इज लाइक प्रीवियस क्वेश्चन ओनली, है ना, प्रीवियस क्वेश्चन की तरह ही है। मतलब ये था पीरियोडिक में आ जा रहा है ना, पीरियोडिक। इसमें ये होगा कि आई में माइनस पाई प्लस ए से 3 पाई प्लस ए जा रहा है ना। तो ये ऐसा जा रहा है। हाँ, तो ये ऐसा हो रहा है कि 3 पाई प्लस ए तक जा रहा है, माइनस पाई प्लस ए से जा रहा है ना। तो a plus b by x, okay, 2 pi plus 2a. Okay, so a plus b minus x will write here. So this is what, 2 pi plus 2a minus x minus a minus pi, and in sign we will be having 2 pi plus 2a minus x by 2 dx. So we know it using property number 6, I think. Property number 5, whatever, okay. This is minus pi plus a, 3 pi plus a, okay. So this is nothing but, it is again pi plus a minus x, which we can say that x minus pi minus a. And this is nothing but sine pi plus a minus x by 2. So sine pi, if you do it like minus x minus 2a by 2 dx, it is going to be minus pi by pi plus a to 3 pi plus a, x minus a minus pi, sine pi minus x is something sine only, it is x by 2 minus a dx, okay. This is a bit good question. Sine a plus b, sine a. So this is also I, and this is also I. So we'll add 2i, okay. We are going to get minus pi plus a, 3 pi plus a. This is x minus a minus pi. We have sine x plus sine x by 2 minus a. This is sine c plus sine d. So we have simply 2i equal to minus pi plus a to 3 pi plus a. This is x minus a minus pi to sine, it was x by 2, okay, sine c plus d by 2, and cos c minus d by 2, it is cos a by 2 dx, okay. This is 2 sine, okay. So if you see, it is 2i cos a by 2, 2, and we are left with nothing but it is I only. So we can do 2 to cancel, we can say I 1 minus cos a by 2 equal to 0. Can we say that cos a by 2 equal to 0? So can we say that a by 2 is 2n pi plus minus pi by 2? So can we say that a is can we say that a is equal to 4n pi plus minus pi? That means a is equal to pi 4n plus minus 1. So now we'll start putting the value. So a is equal to 4n plus minus 1 into pi. So we'll start from the 0. So n is 1. So this is possible as n equal to 0. Pi 5 pi 9 pi. This is 10 pi. This is 100 pi. 100 into 100 pi. So it will go up to 1 5. So the difference is 9. Yes, 13. 97 pi. It will go up to 97 pi. And 1 will starting with 0. It is minus pi 3 pi 7 pi up to 97 99 pi. So what are we getting is that all the odd pi, all the odd multiple of pi are there. So 1357. So 0 to 100, 1357, it is 2n minus 1. So 50, total 50 A's. 50. Total 50 A's are possible. So we got this answer. Property number 7. No, it's a periodic property, okay? Periodic property, okay? We are told that if 0 to n capital T fx dx is equal to n 0 to t fx dx, then f x plus t is equal to fx, where t is period of fx. Okay, small example. If I is integration 0 to 1000 e to the power x minus greatest integer x dx. So what will happen in periodic function? We are majorly going with the graphs. If we go with the graphs, this is nothing but 0 to 1000 e to the power fractional x dx. So fractional x is what? E to the power x from 0 to 1. It will go like this. 1 to 2. It will go like this. 2 to 3. It will go like this. So it will go up to 999 1000. So can we see that it is 1000 times 0 to 1 e to the power x dx, and e to the power x dx is what? Integration of e to the power x dx is what? E to the power x. and in which we have to put from 0 to 1000. It is nothing but 0 to 1. Okay, sorry, it's a 1. It is 1000 e minus 1. So this is the answer. So in periodic function we have some more things, okay, to discuss. Okay, we have few notes. In periodic function we have few notes. Okay, 0 to n capital T fx dx is n times 0 to t 0 to t, okay, fx dx, n belongs to integer. Z means integer, okay, integer. Q means rational number, okay. Second number, a to a plus nt fx dx is nothing but n times 0 to t fx dx, n belongs to natural number. Third, mt to nt fx dx is nothing but n minus m 0 to t fx dx, where n m belongs to natural number. Fourth number, nt to a plus mt fx dx is m minus n 0 to t fx dx plus 0 to a fx dx. Okay. Fifth, a plus nt to b plus nt fx dx is nothing but a to b fx dx, and belongs to integer. So I think you understood. Yes, I think you understood that one. In this type of question, minus 3 to 5 e to the power fraction x dx. The period of fraction x is what? 1. So we'll simply do n to m. It's like n to m to n fx dx. mt to nt. It is what? N minus m integration 0 to t fx dx. So the period of this is what? 1. So 0 to 1 e to the power x dx m minus of n, which is 8. So it is nothing but 8 e minus 1. I think you got it. Okay. Second question. So we have I equal to summation n equal to 1 to 1000 and integration n minus 1 to 1 summation of cos 2 pi x dx. If you see cos 2 pi x graph, n minus 1 to n, that means the time period of this one is what? 1. So this is 1. Okay. So this is simply what? Summation n equal to 1 to 1000 n minus 1 0 to 1 mod cos 2 pi x dx. And what will happen? It will start like this. This is 1 and it is mod. So it will go like this and this will get shifted to this side. So it is what? If you try to say, it is 2 times. It is 4 times of 0 to 1 by 4. So this is 1. This is 0 to 1, isn't it? So we'll divide it into 4 times. We'll tell 4 times 0 to 1 by 4 cos 2 pi x dx. And this is 1. And it will become 1000 times the same. It is nothing but 4000 cos 2 pi x will get 2 pi sin 2 pi x. So sin 2 pi x 0 to 1 by 4. It is nothing but 2000 by pi and it is going to be 1. That's all. This question is a tricky question. Try to solve it. Using periodic we are trying to solve it. Okay. So we'll consider I equal to 0 to 11, 11 to the power fractional x, greatest integer x minus greatest integer is fraction x dx. Okay. So we know that the time period of fractional x is 1. So it will come out to be 11 minus 0, 0 to 1, 11 to the power fractional x dx, and the integration of 11 to the power x dx 0 to 1 into 11. So it is nothing but 11 into 11 to the power x ln 11 0 to 1. So it is 11, at 1 it is 11, at 0 it is 1 upon ln 11. We are told that it is equal to k upon ln 11. Can we say that k is equal to 110? Okay. These are the periodic question. If you wanted to be expert, you can solve it. So this is first question, this is second question, this is third question. So first question, this is minus 1 to 20 plus 1 by 2 e to the power fractional 2x dx. Okay. So the period of this is what? 1 by 2 is the period of fractional 2x. So can we say that it is nothing but minus 2 by 2 to 41 by 2 e to the power fractional 2x dx. Now we remember that if it is mt to nt e to the power some fx, okay, fx dx, we'll simply write it n minus m 0 to t fx dx. So can we say that it is m is minus 2, n is 41. So it is 41 minus minus 2, 43, 0 to 1 by 2 e to the power x dx. Yes. So the integration is going to be 43 by 2 e minus 1. Going with second one. So it is 0 to the power 4 pi by 2 pi by 3 mod sin x dx. Okay. Third number we will solve it. Okay. So if we go through the graph of sin x, it is somewhere like this. So can we say that it could be solved further as 0 to 4 pi mod sin x dx plus 4 pi to 4 pi plus 2 pi by 3 mod sin x dx. So 0 to, it's what, 2 pi 4 pi. Can we say it's a 4 0 pi by 2, this is 2 pi and we'll have 4 pi, this will be 4 pi, yes. So we can see that it is 1 2 3 4, 8 multiples, so 8 times of 0 to pi by 2 sin x dx, and it is 0 to 2 pi by 3 sin x dx. Okay, so we can simply solve it as 8 sin x is minus cos x, so it is 1 cos minus 1 by 2, so it is nothing but 3 by 2 25 by 2. This is the answer. Fourth one, do you have a space? No. Fourth one, if you see, sin x will, sin to the power 4 will come out to be 1 minus cos 2x by 2 whole square. Okay, my saying is that it is pi to 3 pi by 2, and we can simply write this as 1 minus 2 sin square x cos square x divide by 2 multiply by 2 dx. It is pi to 3 pi by 2. We have dx here and we have pi to 3 pi by 2 sin power 4 sin square to the power 2x by 2 dx. So we can solve this one. Kindly solve it, okay? fx is a function defined and fx plus f minus x equal to 0, that means fx is odd function, then x belongs to minus ty2 to ty2, okay, has a period t, okay, then prove that this is a periodic function. Phi x is equal to a2x ft dt, okay. So now what will happen, we have to show that this is periodic. Hmm, we'll break it from a to a plus t ft dt, a plus t to a plus 2t ft dt, dot 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 a plus nt to x ft dt. If we write it, it is nothing but 0 to t ft dt, 0 to t ft dt, dot 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 0 to t ft dt, and it is 0 to x ft dt. So if you try to see this all, it was 1 2 3 n, it is n times of 0 to t ft dt plus 0 to x ft dt, okay. So if you do phi x plus t, it is nothing but n 0 to t ft dt plus 0 to x plus capital T ft dt. So in place of t, we'll put x plus t. So we can simply say that hmm, if we put t equal to x plus t, t is from 0 to x plus t, and we are putting now x plus t in this place, which is x plus t, t plus capital T we are making it, okay, it is 0. So this z is from, hmm, what are we going to do? T is from 0 to x plus t. So what will happen if we try to manipulate it? It will come out to be minus t to x ft dt. Okay, this is n 0 to t ft dt. Okay, and if we go further, okay, further in the sense, if we go further here, so it is phi x plus t equal to, we have n 0 to t ft dt. Yes, so we have plus, if we put t equal to minus t, this is minus x to t f minus x plus dx. Okay, so we are trying to show it periodic, so this is coming this value. My saying is that with the varying of t, this is also varying, so it's a periodic, normally that. Okay, now this is the good question you should all try. Okay, this is the good question you should all try. I am helping you to solve this. Okay, fx be a function satisfying this. So what will happen, fx plus fx plus 2 is equal to 10. We'll put x equal to x plus 2. We are going to get fx plus 2 fx plus 4 equal to 10. We are going to subtract 1 with 2. We are going to get fx minus fx plus 4 equal to 0. So we can say that fx is equal to fx plus 4, which is equal to fx plus capital T. So capital T is nothing but 4. The period of this function is 4. This is a periodic, so option A is correct. Now going with option C or D. We will take C or D. Okay, let's take, it is minus 1 to 7. It is fx dx. So this has period 4. So what will happen if you see 7? It is 7 minus of minus 1 into period 0 to 4 fx dx. Yes, okay, this is 8 0 to 4. Mm, no, what will happen, see, we could find period very nicely. Okay, we'll shift it one. Okay, we'll make 0 to 8 fx dx, and now we know that it is 0 into 4, and this is 2 into 4 fx dx. So it is something 2 minus 0, 0 to 4 fx dx. This is it. Okay, okay, okay. We know that using one of our property, that it's a 2. Okay, 0 to a fx dx plus 0 to a f 2a minus x dx. So if we are doing 0 to 2a, if we consider that this is 0 to 2a fx dx, we can do it in this way. So this is nothing but 2 times of 0 to a, which is 0 to 2 fx dx plus 0 to 2, it is 4 minus x. So it is 4 minus x. So when x is 0, it is 4, and when x is 1, it is 3. So it is going somewhere like this only. So it is nothing but 2 times of 0 to 2 fx plus f4 plus f2 plus x dx, which is nothing but 2 times of 0 to 2 10 dx, which is nothing but 40. Okay, 40, we are getting 40. So that's all. Okay, now we are on lecture 5. This is very simple lecture. This is very simple lecture. Okay, it will not take any effort by you to go through these lectures. Okay, okay, we'll cover everything. Okay, so try to keep patience. We'll cover everything. Hello, Ayush Maheshwari. Yes, Ayush, tell me. Hello, Ayush, tell me. Now we are on derivative as an antiderivative. So it's a Leibniz theorem. Leibniz is trying to say something to us. Let's listen. हम लोग सुनते हैं क्या लेबनिज बोल रहा है ना. लेबनिज का बोलना है इफ fx is a continuous function, then derivative of integration of hx gx fx dx, okay, is f gx g dash x minus f hx h dash x. तो इनका ये बोलना है ना, इनका इतना ही बोलना है. फॉर एग्जाम्पल, अगर x से एक्स स्क्वायर का डेरिवेशन करते हैं और ये फंक्शन है x प्लस वन डी एक्स, इसको i मानते हैं, तो डी आई बाय डी एक्स क्या होगा? वो होगा नथिंग बट एक्स स्क्वायर प्लस वन टू एक्स डेरिवेशन ऑफ एक्स स्क्वायर माइनस एक्स प्लस वन डेरिवेटिव ऑफ एक्स विच इज वन. तो ये होगा, है ना. तो इनका इतना ही बोलना है और हमें इनका इस्तेमाल करना है ना. हेलो आयुष, हेलो. हेलो आयुष. तो हम लोग आगे बढ़ते हैं. तो ये करना है एफ डैश एक्स. तो हमें क्या करना है? एफ डैश एक्स ये सिंपली रूट 10 एक्स स्क्वायर और डिफ्रेंशिएशन ऑफ एक्स स्क्वायर क्या होगा? 2x माइनस रूट 10x डिफ्रेंशिएशन ऑफ x क्या होगा? 1. तो ये इसका सॉल्यूशन हो गया. दिस इज द सॉल्यूशन. तो इसमें ज्यादा कुछ करना नहीं है. इस क्वेश्चन में एफ डैश एक्स 1 अपॉन ln एक्स स्क्वायर डिफ्रेंशिएशन ऑफ एक्स स्क्वायर क्या होगा? 2x माइनस 1 अपॉन, और ये एक्स क्यूब होगा, है ना. ये एक्स क्यूब होगा 3x स्क्वायर. पहला तो एक्स क्यूब आ रहा है ना फिर एक्स स्क्वायर इंटू 2x. अब पुट x इक्वल टू ई. इट इज एफ डैश ई इज इक्वल टू 3e स्क्वायर बाय 3 माइनस 2e बाय 2 विच इज नथिंग बट e स्क्वायर माइनस ई. तो ये सब बेसिक क्वेश्चंस हैं. अगला क्वेश्चन, लिमिट x टेंडिंग टू 0 प्लस दिस थिंग. तो ये हम मान लेते हैं i. इंटीग्रेशन इज हैपनिंग विद रिस्पेक्ट टू dt. dt के रिस्पेक्ट में इंटीग्रेशन हो रहा है, तो हम लोग x टू द पावर 4 को बाहर ले लेते हैं और ये रह गया 0 से एक्स स्क्वायर साइन रूट टी 10 रूट टी डी टी. अब x पे ये 0 हो रहा है, लिमिट x टेंडिंग टू 0 प्लस. तो हम लोग एल हॉस्पिटल लगा सकते हैं. तो ये हो गया साइन रूट अंडर एक्स स्क्वायर इज x 10 रूट अंडर एक्स स्क्वायर इज x इंटू 2x अपॉन 4x क्यूब। अब फिर से है लिमिट x टेंडिंग टू 0 प्लस, तो इधर देखिए x, ये एक्स स्क्वायर बच जाएगा, 10x/x साइन एक्स बाय एक्स, ये 1 है, तो आंसर हो गया 1/2, है ना। अब इसमें है फाइंड द पॉइंट ऑफ मिनिमा। तो पॉइंट ऑफ मिनिमा के लिए क्या करते हैं हम लोग, पहले एफ डैश एक्स को 0 रखते हैं। तो एफ डैश एक्स क्या हो गया, x-1 होल स्क्वायर, x-2 होल स्क्वायर, इसको 0 रखते हैं और नंबर लाइन पे प्लॉट करते हैं। तो नंबर लाइन पे 2 1 आएगा। सो 2 के आगे जाएंगे तो ये प्लस होगा, और ये इवन पावर है तो साइन चेंज नहीं होगा, फिर इसके पीछे माइनस होगा। तो ये फंक्शन डिक्रीजिंग और फिर इंक्रीजिंग है ना। तो लोकल मिनिमा, पॉइंट ऑफ मिनिमा क्या हो गया, x=1। तो यूजिंग लेबनिज फॉर्मूला हम लोग आसानी से ये सब सॉल्व कर सकते हैं। अब ये एक नया प्रोफाइल आया है ना, दिस इज अ न्यू प्रोफाइल। जिसको हम लोग क्या बोलते हैं, इस प्रोफाइल को, वेट अ सेकेंड, लेबनिज फॉर्मूला यूजिंग, दिस इज कॉल्ड लेबनिज फॉर्मूला यूजिंग मल्टीपल वेरिएबल्स, है ना। ओके, तो अब देखो यहां x⁴ है और ये ln x है, तो वी हैव टू इंटीग्रेट दिस थिंग। ओके, तो हम लोग इसको i मान लेते हैं, 0 to 1 x⁴ -1 ln x dx, है ना। तो इसमें ये करेंगे कि हम लोग i को b के रिस्पेक्ट में डिफ्रेंशिएट करते हैं। तो ये होगा, ये 0 to 1 हो गया, और ये b ये क्या हो गया, x⁴ a⁴x, यहाँ x कांस्टेंट हो गया है ना, तो b के रिस्पेक्ट में डिफरेंशिएट कर रहे हैं। तो ये हो गया b a⁴x, क्या होता है, ये a⁴x जैसा हो गया ना, क्योंकि b हो गया, तो इसका होता है x⁴ ln x अपॉन ln x dx, ये हो गया। ये x⁴ b इज वेरिएबल्स, x इज कांस्टेंट, तो ln x कैंसिल हो गया, तो हमारे पास सिंपली क्या बचा, 0 to 1 x⁴ dx। इसका सिंपली इंटीग्रेशन क्या होगा, x⁴ b+1 अपॉन b+1, 0 to 1 रखो, तो ये हो गया 1 अपॉन b+1। अब di/dv इज 1 अपॉन b+1, तो di का इंटीग्रेशन करो, और यहाँ db अपॉन b+1 का इंटीग्रेशन करो, तो i विल बी नथिंग बट ln b+1 प्लस सी है ना, एल एन बी प्लस वन प्लस सी। अब देखो, जब बी जीरो होता, अगर जब बी जीरो होता, व्हेन बी वॉज इक्वल टू जीरो, तो एक्स टू द पावर बी जीरो होता, तो आई वुड हैव बीन इक्वल टू जीरो। तो जब बी जीरो है, अगर बी जीरो होता तो इस इक्वेशन में, ऑन द गिवन इक्वेशन, आई विल बी इक्वल टू जीरो। सो व्हेन आई इज इक्वल टू जीरो, इट इज एल एन वन प्लस सी। So we can see that C is equal to 0. So I is nothing but ln B plus 1. Okay. So this is one of the good concept. अब इस इक्वेशन में x है ना, तो इसको कैसे करना, तो इसको I मान लो, 0 to 1 tan इनवर्स ax x रूट अंडर 1 माइनस एक्स स्क्वायर dx। तो इसको हम लोग पहले a के रिस्पेक्ट में डिफरेंशिएट करते हैं, डी आई बाई डी ए। तो ये सिंपली 0 to 1 है, टेन इनवर्स ए एक्स क्या हो जाएगा, 1 प्लस ए स्क्वायर एक्स स्क्वायर, और डिफ्रेंशिएशन ऑफ ए एक्स ए हो जाएगा, और इधर हम लोग के पास एक्स है, रूट 1 माइनस एक्स स्क्वायर, और फिर dx है ना। तो अब ऐसा हो गया। अब इसको सॉल्व करना पड़ेगा, इसको सॉल्व करना पड़ेगा। ए एक्स को टेन थीटा मानते हैं, ओके। तो हमारे पास बचेगा डी आई बाय डी ए इज नथिंग बट 0 to 1, ए डी एक्स बचेगा सेक स्क्वायर थीटा डी थीटा, और ये हुआ सेक स्क्वायर थीटा, ये हो गया टेन थीटा बाय ए, ये हो गया रूट अंडर 1 माइनस टेन स्क्वायर थीटा बाय एक्स, एक्स स्क्वायर हो गया टेन स्क्वायर थीटा बाय ए स्क्वायर, जो एक मुश्किल की घड़ी आ गई, है ना, वो मुश्किल की घड़ी आ गई है ना, एक्स को नहीं रख पाएंगे। So we'll put x equal to sine theta because we have to think about this thing. If these are able to come out, we can solve it simply, isn't it? तो ये 0 to पाई बाय 2 हो जाएगा लिमिट, और x साइन थीटा हो गया तो dx हो गया cos थीटा, यहाँ a है, ये साइन थीटा, ये d थीटा है, और ये हो गया 1 प्लस ए स्क्वायर साइन स्क्वायर थीटा, और ये साइन थीटा हो गया 1 माइनस साइन स्क्वायर थीटा कॉस थीटा हो गया। तो ये कैंसिल, तो हमारे पास नॉर्मली बच गया 0 to पाई बाय 2 ए d theta upon 1 plus a square sin square theta sin theta. Okay. Okay, okay. Okay, okay. This is differentiation with respect to a, isn't it? So 1 plus a square and it will become x because a is differentiated. So x will get cancelled, isn't it? So it will be becoming x is sin theta will get cancelled. Now we are left with only this thing. This is 1. So we are left with di by dA 0 to pi by 2 d theta will take cosec square theta plus a square. Okay, into cosec square theta. So it is nothing but 0 to pi by 2 cosec square theta plus into d theta, and here we are left with a square plus 1 plus cot square theta, isn't it? So if we keep it at z, this is minus dz. So it is nothing but 1 upon root under a square plus 1 z square plus a square minus dz. Tan inverse cot theta upon root under a square plus 1, and this is 0 to pi by 2. Okay, at pi by 2 cot is 0, at 0 it is infinity, at pi by 2 it is infinity, so it will come out with pi by 2. So it is nothing but pi by 2 root under a square plus 1. Now we have di, so I will become integration of pi by 2 dA by root under a square plus 1. So which is nothing but pi by 2 ln a plus root under a square plus 1 by standard formula. And when a was 0 initially, so I was 0, so c will become 0. So this is the function. Okay, this is simple Leibniz formula. Differentiate and put tangent at this, so it is also simple. This is simple, 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 simple. Okay, this question I am trying to do it. Okay, 0 to pi ln 1 plus b cos x dx. So I will consider this I is in the form of b, so di by dv is nothing but 0 to pi 1 plus b cos x into cos x, because we are differentiating with respect to b. Okay, now what will happen? So we'll convert this into half angle. Will we convert it into half angle? 1 minus 10, 1 plus 10. Okay, let's try it. We'll try it at half angle, okay? 1 minus 10 square x by 2, and here it will come out to be 1 plus 10 square x by 2 plus b 1 minus 10 square x by 2. It is dx. Okay, it is 0 to pi b plus 1 1 minus b 10 square x by 2 dx. This is 1 minus 10 square x by 2. We'll take 1 minus b common, okay? This is 1 minus b, okay? Okay, so we are getting something di by db into 1 minus b. Okay, we should be having some space. 0 to pi. This is dx upon, we'll consider b plus 1 upon 1 minus b as alpha, okay? And this is 10 square x by 2, okay? And we have minus 0 to pi dx 10 square x by 2 upon 10 square x by 2 plus alpha, okay? So we'll add alpha, subtract alpha. So if we add alpha, we'll have to subtract alpha. So it will become nothing but alpha plus 1, and this is nothing but minus pi, and this is alpha plus 1 dx upon alpha plus 10 square x by 2, 0 to pi. Now applying property number 6, we are trying to put in place of x a plus b minus x. So it will become cot square x by 2, and it will go like this, and it will go multiply with this, okay? Mm, or what can we do? In place of adding alpha, mm, we have 10 square x by 2, we have pi minus pi there, okay? At pi by 2 it will become cot square x by 2. Okay, we can solve it. So I'm trying to solve it. Okay, we'll consider this as I2. So I2 upon alpha plus 1 is 0 to pi. It is 10 square x by 2 dx alpha 10 square x by 2 plus 1. Okay, I think it's a visible. So we are doing a plus b minus x, which is pi minus x by 2. So it is coming out to be somewhere like this. Now we'll multiply alpha I2 with alpha. Okay, we'll multiply I2 with alpha and we'll add I2 alpha plus 1. So we are going to get 0 pi 10 square x by 2 1 plus alpha 10 square x by 2 dx. So this is going to be 1. Okay, so we are getting pi and this side we are getting I2. So I2 is pi. Okay, okay, I think so. This is pi. Pi minus pi 0. So di by dv is coming out to be 0. Okay, so we can similarly calculate the value. Okay, I think you got it. If you're in mistake, kindly check it. This question is simple. This question is simple, simple, simple. Okay, this question. I am trying to take this question. Okay, n tending to infinity. Apply L hospital. Tan inverse 1 minus 1 by n square minus tan inverse n plus 1 minus 1 upon n plus 1 whole square upon sin inverse n upon n minus 1 by n square minus plus sin inverse n upon n plus 1 minus got plus. Yes, here the minus will come, it will become plus 1 upon n plus 1 whole square limit n tending to infinity. So sin tan inverse 1 is pi by 4 minus 1 by n square limit n tending to infinity. This is minus plus tan inverse n upon n plus 1. This is 1 upon n plus 1 whole square. Okay, this is pi by 2 minus 1 by n square sin inverse n upon n plus 1 1 plus n plus 1 whole square. Okay, I think we will have to go with the expansion, or let's try it by taking LCM. So limit n tending to infinity, let's take LCM. Okay, minus pi n plus 1 whole square plus 4 n square tan inverse n plus 1. This is minus pi n plus 1 whole square plus 2 n square sine inverse n plus 1. So limit n tending to 0, this is pi by 2, so it is 0 by 0 only, okay. So apply L hospital again, okay. This is minus 2 pi n plus 1, it is 4 n sine inverse n plus 1, and here again 2n square root under 1 plus 1 minus n plus 1 whole square. This is in the denominator itself, okay. Numerator will be having minus 2 pi n plus 1. We have 8 n tan inverse n plus 1 plus some bigger term will not come. It will be 1 by n plus 1 whole square, and this is 1 upon 1 plus n plus 1 whole square, the differentiation of this one, into 4n square. Now when we go with n tending to infinity, this is going to be pi by 4, which is 4 pi, 2 pi, this is going to be 0, but this is going to be what? This is going to be 1, 0, this is going to be 0. This is nothing but n plus 1. This question is good, so we'll solve it, okay. This question is good, so we are going to solve it. IIT advanced level, okay. Differentiate it, okay. Okay, what will happen? Mm, this is n, okay. If we differentiate it with respect to x, okay, it is 0 by 0. If we differentiate with respect to x, this will go. So it is tan inverse 1 pi by 4. Tan inverse, okay, this is limit n tending to infinity, okay. It's better to expand it, okay. It is better we will expand it. This is 1 x to the power 0. It is x, okay. The expansion of sine inverse will be similar to that one. Expansion of sine inverse will be how? So right now we don't remember. If we expand it similar to sine x, will it work? That is the issue. So what will happen? In everything we'll try to make some conversion. So x is between 1 by n plus 1 to 1 by n. So we'll put nx. We'll get, in place of x we'll put nx, and which will be from 1 to n plus 1 to 1 by n. We'll have nx n. So this will be z. Z is from 1 to 1 upon n plus 1, okay. So z will be 1, and z is equal to nx, okay. So dz will be n dx. So we are trying to make it simply like n upon n plus 1 to 1, okay. Tan inverse z dz by n. This is 1 to n upon n plus 1 sine inverse z dz by n. Limit n tending to infinity, n will get cancelled, okay. And now if you apply L hospital, we are going to get tan inverse n upon n plus 1, and this is nothing but n plus 1 into quotient formula. If we apply in the differentiation, it is n plus 1 and minus 1 upon n plus 1 whole square, and we have Sine inverse n upon n plus 1, 1 upon n plus 1 whole square. So this will come out to be here. Okay, it is negative. Okay, it is opposite. Okay, so this is going to get cancelled. N is tending to infinity. It is nothing but pi by 4 by pi by 2, which is 1 by 2. This is the simple answer. Okay, this is the simple question. Do it, 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 do it. Now we are moving to Wallis. Okay, so Leibniz formula you just simply have to differentiate. Okay, so Wallis formula, we are on Wallis formula. Okay, Wallis formula is trying to say us that if we have I as a function of m comma n, and we are integrating from 0 to pi by 2, okay, and it is sine x to the power m and cos x to the power n. Okay, if we have to find this value, then I m n will be coming out to be m minus 1, m minus 3, m minus 5, dot 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 1, n minus 1, n minus 3, dot 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 n minus something. Okay, it's 1. Okay, this is m plus n, m plus n minus 2, m plus n minus 4, dot dot dot. It's like 2, I think. It will go like 2 or maybe 2. The last will be 2, isn't it? Into pi by 2. When mn belongs to 2n. Okay, and 2n like 2 lambda. So lambda belongs to integer. Otherwise, it's m minus 1, m minus 3, dot 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 1 into n minus 1, n minus 3, dot 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 1 divided by m plus n, m plus n minus 2, dot 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 up to 2 into 1 only. Okay, m otherwise, we'll simply write otherwise. Okay, so here m and n is even. Okay, this case is otherwise. Okay, so I am giving you all this question to solve using Wallis theorem. So I am giving you 5 minutes to solve this. Okay, and then we'll move to estimation. Solve this. I am giving you 5 minutes. Okay. So using volleys, these all are simpler to solve. Okay. So I'm proceeding with the first question. We have this I minus pi by 2 2 pi by 2. If we expand it, it is nothing but sine cube x cos square x plus sine square x cos cube x dx. If you see, this is odd function and this is even. So this is going to be 0 from minus pi by 2 to pi by 2. So we are left with only sine square x cos cube x dx. 0 to minus pi, it will become, it is even function, isn't it? So minus pi by 2 to pi by 2 will become 2 times of 0 to pi by 2. And now we know that using Wallis theorem, if both are even, it would be multiplied with pi by 2. If it is odd, then we will have simply 2 minus 1, 3 minus 1. 3 minus 3 will become 0, isn't it? And we have 3 plus 2, 5 into 5 minus 2, 5 minus 4, which is nothing but, if you see, it is 2 upon 15. This is the answer. Second question, we have I equal to 0 to pi x sine to the power 5x dx. If we do I equal to pi minus x, a plus b minus x, sine pi minus x is sine x only. If we add both of them, we can say that 2i is equal to 0 to pi pi. If we add both of them, x cancel, it is pi sine x. Now you see that sine x is symmetric about 0 to, in 0 to pi, sine x is symmetric about pi by 2. So can we say it is nothing but 2i equal to 2 pi 0 to pi by 2 sine to the power 5x dx. And now 2 cancel. We have nothing but I equal to I by pi equal to 0 to pi by 2 sine x to the power 5 dx. Using Wallis, this is otherwise case. So we'll go with 5 minus 1, 5 minus 3 upon 5. So here cos x to the power 0 is there, isn't it? So we don't go with 0. Okay. This is 5 minus 0, 5 minus 1, 5 minus 3, which is nothing but 4 2 ja 8. 8 upon 5 into 4 into 2. So it is 1 by 5. So I will send you pi this side, so it will become pi by 5. So I think you got the way to perform Wallis theorem, isn't it? So third number. So in I will perform a plus b minus x. So it is 0 to 3 by 2, 2 minus x, 3 by 2. It is x to the power 1 by 2 dx. We will add I and this side. So we'll get 2i equal to 0 to 3 by 2. If you see, it is nothing but root under 2 minus x into x. 2 minus x plus x dx. And it is nothing but I equal to 0 to 3 by 2 root under 1 minus this is nothing but minus x square plus 2x. So we'll have to add we have to subtract minus 1 and add minus 1, which is x minus 1 whole square dx. So by standard formula we know this. It is what? Solve it. Let's solve it. It's I equal to 0 to 3 by 2 1 minus x minus 1 whole square dx. So we'll put x minus 1 equal to cos theta, or we'll keep it sin theta. Okay. So dx equal to cos theta d theta. So I is equal to, we don't know limit right now. Okay. It's a cos theta, cos square theta d theta. It is nothing but 1 minus 1 plus cos 2 theta upon 2 d theta integration. It is theta plus sine 2 theta by 2 whole 2. Limit we don't know right now. uh, Theta is sine inverse x minus 1 plus x minus 1 root under 1 minus x minus 1 whole square upon 2, and x is varying from 0 to 3 by 2. Now you can solve the value. At 3 by 2 it is 1 by 2 at minus 1. Okay. 1 by 2. Putting 3 by 2 will give us 1 by 2. So pi by 6. At 0 it is minus 1 plus pi by 2. At 3 by 2 it is 1 by 2 root 3 by 2. At 0 it is 0. So this is the answer we are going to get from this question. Okay, we have more space. Fourth question, x sin square x cos square x. 0 to 2 pi, I think. X sin square x cos square x dx. We'll consider this as I. I will put 2 pi minus x. 0 to 2 pi. 2 pi minus x. Sin 2 pi minus x is sin square x. Cos 2 pi minus x is cos square x. We'll add both of them. We'll get 2i equal to 0 to 2 pi. 2 pi sin square x cos square x dx. Now we'll get simply I by pi, and if you see both of them are even. Okay, so this is nothing but, if you see pi by 2 minus x, it is coming out to be the same. So pi by 2 is period of this one. So we'll simply divide it by 4, 0 to pi by 2. Sin square x cos square x dx. This is 4 pi I. This is even. So we know that we have to multiply this with pi by 2, and it is 2 minus 1. 2 minus 1. This is 2 plus 2, 4. 4 minus 2. So this is nothing but pi square by. Okay, this is the answer for this one. So we simply know that using Wallis theorem, if n is odd, it is rational. If n is odd, it is rational using Wallis theorem. Okay, if n is odd, it is m minus 1, m minus 3 into 1. Okay, n minus 1, n minus 3 dot 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 1 upon m plus n minus 2 dot 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 into 1 when n is odd. Otherwise, pi by 2 into m minus 1, m minus 3 dot 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 1, n minus 1, n minus 3 into 1 upon m plus n minus 2 dot dot dot. So in is irrational if n is even. Okay, no, it is otherwise. This is otherwise case. Okay, here m n belongs to even. Okay, so we are told that in is increasing in the sequence. So what will happen? Okay, so this is, we did option A, option B we did. In going with option C or D, what will happen? Sin x to the power n is coming as n minus 1, n minus 3, 1. and it is n minus 2 and n minus 4 dot dot dot. Depending on even odd, it will be pi by 2 or not pi by 2. So what will happen when it is odd? It is odd, it is multiplied with 1. Otherwise, if it is even, it is multiplied with pi by 2. So if n is 3, it is what? 3 minus 1. 3 minus 3, not possible. And 3 minus 0, 3 minus 1, 3 minus 2, 1. It is 2 by 3. Now if it is n equal to 4, it is 4 minus 1, 4 minus 3, 4, 2, pi by 2. It is what? 3 pi by 16, and this is 2 by 3. So it's a 3 pi by 16, and this is 2 by 3. So which is smaller? It is 0.6, and it is so n4 is less than n3. So we can say that it is decreasing. Okay. Now we are coming to the most important topic of definite integration, which is estimation. Which is estimation. Most important topic. So estimation. In estimation, what will happen? Okay. So in estimation, what happened? One, for a for a monotonic for a monotonic function. Okay, this is y, this is x. Monotonic function, I mean that if it is increasing from a to b, and if it is fa, monotonic function, 1 for a monotonic function like this. This is fa, this is fb. So we can say that in one integration a to b, fx dx is bigger than b minus a into fa, and it is less than, if we go somewhere like this, it is b comma fb, which is fb into b minus a. Looking picture 1, can we say this thing? Second, looking in this picture, can we say that fx dx integration a to b? So by looking the picture, can we say that it is less than fa b minus a and more than fb b minus a? So this is our estimation that area of this will fall in between this and this. So this is our estimation. Okay. Now we can have some different function. We have some functions like this. Now this is a, this is b. Okay. This is y equal to fx. Can we say integration a to b fx dx is this area? So fx dx integration a to b is this is fb. Okay, fb less than fb b minus a, and can we say that it is bigger than, if this point comes out to be c, c into f b minus a. Oh, this is fc into b minus a. This is b minus a into fc. So this is the inequality. This is the inequality we are trying to understand. Okay. So in estimation we don't have any other thing. Okay. So we'll try to use estimation question by question. Okay. And we can say that this could be the minimum area and this could be the maximum area. So this is it. Can we find any more scenarios? So third point, I would like to say that integration a to b fx dx, this mod is less than equal to integration a to b fx dx. Can we say this? See, this area will be having something negative, something positive, but this will be having everything positive. So can we say this thing? So similarly, the fourth one, if fx is bigger than equal to 0, if fx is bigger than equal to 0 in a to b Can we say that a to b fx dx is going to be bigger than equal to 0? If this is like this, can we say that this area is completely positive? This is what I am trying to say you all. Okay, so these are the estimation. Now we have few questions on estimation. So where the difficulty of estimation is hidden, it's hidden in finding the nature of curve, how the curve is going, and based on that judging the estimation. So this is the difficulty of estimation, or you can say this is the difficulty of inequality. So try this question using estimation. So now we are starting with this question with the estimation. Arrange the following in ascending order. Okay, arrange the following in ascending order. So let's arrange it. Which is decreasing, which is not decreasing. So x equal to 1. This will be, so what will happen? We will first start x square in 0 to 1. Okay, in 0 to 1, x square will be bigger than x cube. Okay, boss. 2x square will be bigger than x square, will be bigger than x square plus x cube, because x cube will become more fraction, isn't it? Okay, now we'll multiply minus. So minus 2x square will become lower than minus x square, will become lower than minus x square minus x cube. We'll add 9. Okay, now we'll divide everyone. So this ratio is going to invert. Okay, so this is going to invert. So we could arrange it in ascending order, isn't it? Okay, sorry. X square is somewhere less than x square. We are adding something, isn't it? So what is happening in x square? We are adding something, so it will be bigger than this one, and this x square is bigger than x cube. So this is what happening. Okay. Now what will happen? We have to find. This is part one. Part two. We have to find integration 0 to 1, 1 upon 9 minus x square minus x cube dx. Okay. So what can happen is that we can say that this function is less than 1 minus 2x square dx and bigger than dx upon 9 minus x square 0 to 1. Now we'll find the integration for this one and integration for this one. So integration for this one is what? A square minus x square is nothing but it is 3 minus x, 3 plus x, so 6. 1 by 6 ln 9 minus x square 0 to 1, and this integration is like I, and this is going to be uh, if we send 2 out, 9 by 2, 3 by root 2, so it is going to be somewhere 1 by 6 root 2 if you do integration. Okay, ln 5. Okay, so we could prove using estimation. So we are finding function nearby and trying to estimate. In this question we have to try to find estimation. So first we'll take the function as 5 minus x 9 minus x square. We'll differentiate it. It is 9 minus x square minus 1 minus 5 minus x minus 2x upon 9 minus x square whole square. It is somewhere x square minus 9, and if you see it is plus 10x minus 2x square upon 9 minus x square whole square. So it is nothing but minus x square minus 9 plus 10x upon x square minus 9 whole square. So we'll see the nature of this curvature. Okay, so it is x square minus 10x plus 9 equal to 0, x equal to 10 plus minus b square minus 4ac upon 2a 5 plus minus 4. This is 1 comma 9. Okay, 1 comma 9. So what will happen? We are getting 9 and we are getting 1. At 9 plus it is positive, negative. This is negative, okay? And positive, negative. So the curve is somewhere coming out to be decreasing. Extending to infinity is 0. Extending to infinity is 0. Extending to 0 is 5 by 9. Extending to infinity, this is infinity. This is 0. Ah, oh, oh. Okay, one more thing. In this critical, we are getting plus 3, minus 3 also. This is minus, so plus, plus, minus minus. Okay, so this is not going to disturb us. So x tending to minus infinity is this. So x tending to infinity minus infinity, we take x common. We have 1 minus 5 by x. We take x square common. 1 minus 9 by x square. This x cancelled. X tending to minus infinity, it is 0 minus. Oh, 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 oh. Did we do something wrong in differentiation? This differentiation is wrong. Let's check it. Minus 1, 9 minus x square. Minus 5 minus x. 9 minus x square whole square. Minus 2x plus minus 9 x square. Hmm, it is showing decreasing. Okay, so it is decreasing 0 to 2, 0 to 1, 0 to 1. It is saying it is decreasing. Okay, and 1 to 2, it is increasing. Okay, so this is the plot. So if you see estimation at 1 it is 5 by 9 into 2, and it's less than, the area is this. We'll see the maximum value is at 0, it is 5 by 9. At 1, okay, at 1 it is 4 by 8, 4 by 8 into 2. This is the area at 1. And at 0 it is 5 by 9. At 2 it is 3 by 7. So which is bigger, 5 by 9 or 3 by 7? It is point 4. This is 0.5. So we can say 5 by 9 into 2, or we can say that it is less than 3 by 7 into 2. So 6 by 7, and it is 6 by 5. It is, if it is less than 6 by 7, it is less than 6 by 5. So this is the way we are estimating. Okay, so estimation for this thing. So we have nothing but it's a y x. In x belonging 0 to 1, x square is less than x, e to the power x square is less than e to the power x. Okay, so e to the power x will go like this, then e to the power x square will go like this. This is e to the power x square, this is e to the power x. So what will happen, this graph will be somewhere having minimum value of 1. Okay, this area is having 1, and this is what, Can we say that e to the power x squared dx integration 0 to 1 is bigger than uh, using rectangle, okay, and using triangle, okay. So in rectangle form, can we say that using rectangle form, this is rectangle, we e to the power x square. So at x equal to 1, it is e is less than e into 1 and bigger than 1 into 1. Can we say that it is bigger than 1? 0 to 1 e to the power x square dx, which is less than e, using triangular form, okay. So it is this curve, which is e to the power x square, okay. This is this curve, e to the power x. So we have to go with the triangular form, in which we can say this rectangular from this triangle, and this triangle, the straight line joining 1 and e. This could be the area, and this area we can say O, A, B, C, D, okay. So we can say that using triangle integration 0 to 1 e to the power x square dx, okay, is less than area of this triangle is what? It was 1. So 1 plus area of this triangle is what? This is 1, and this is 0, this is 1, and this height is what? This is e, so e minus 1. E minus 1 by 2, and this is bigger than 1. So can we say that it is less than e plus 1 by 2? This I is bigger than 1. So this is the way we are trying to find the estimation, okay. Now estimation for this, using this, we can say that e to the power x square dx 0 to 1 is less than 0 to 1 e to the power x dx. So we can say that it is e minus 1, okay. And we know that this is bigger than e to the power 0 dx 0 to the power 1. So that it is nothing but 1. So I is less than e minus 1, bigger than 1. So if you see this function wise, we got approx result. It is what? 2.73 minus 1, 1.73, and it is what? 3.73 upon 2, which is 1.8. So this is approx. So we'll write a note. Estimate area is accurate when we use nearest function and it is more accurate than it is more accurate than geometrical area. So our functional area calculation is more better than any geometrical area. So in this what will happen? X is bigger than x square minus x is less than minus x square e to the power minus x is less than e to the power minus x square. Okay, so e to the power minus x cos square x is less than e to the power minus x square cos square x. We integrate 0 to 1, integrate 0 to 1, it is less. So sin x belongs to 0 to 1 in x belongs to 0 to pi by 2. So this is fraction. Okay, so what will happen? Sin x n plus 1 will come out to be smaller than sin x whole square. Hence, and sin x is positive, so it will be bigger than 0. So integration sin x to the power n plus 1 dx 0 to pi by 2 is less than 0 to pi by 2 sin square x dx, which is positive. Got it? So we have to calculate the estimation. So calculate the estimation. In this, how to calculate the estimation? So first of all, we have to check the nature of the graph. First, we have to calculate the nature of the graph. So fx is equal to x to the power x. So f dash x will come out to be differentiation of e to the power x ln x, which is nothing but x to the power x, which is the same 1 plus ln x, so which is equal to 0. So x will come out to be 1 by e, so 1 by e plus 1 by e plus is positive, otherwise negative, so decreasing, increasing. So the curve is coming out to be geometrical interpretation. It is somewhere coming out to be like this. This is x equal to 1 by e. So can we say that integration 0 to 1 x to the power x dx, at 1 it is 1, isn't it? And this is 1. So overall area is what? Less than 1. And it is what? More than at x equal to e by e. X equal to 1 by, it is 1 by e to the power 1 by e into 1. So this is what? This is this. So we got the answer. X cube cos x 2 plus x square. Now in this what to do? Ooh. Okay, okay. So we'll choose fx, which is x cube plus 2 plus x square. We'll choose the nature of this curve, and then we'll do integration of cos. No. We can do it in multiple ways. So x belongs to 0 to 1. When x is 0, cos 0 is 1. When x is 1, cos 1 will be bigger than cos pi by 3. Pi by 3 is what? 1 point something, which will be bigger than 1 by 2. So we can say that cos x is decreasing. So cos x is decreasing. So what can we say that at 0 it will be maximum? Okay, at 0 it will be maximum. At 1 it will be this thing. And if you want to find integration 0 to 1, we can simply solve it. This is estimation. So if we try to solve it, so we have to simply solve this, isn't it? So I will try to solve simply this thing. Okay, integration 0 to 1 x cube 2 plus x square dx. So this is 0 to 1 x square, we have x, we'll add plus 2 minus 2, and we have dx x square plus 2. It will go further. It is nothing but 0 to 1 x dx minus 2x dx 0 to 1 x square plus 2. It is coming in ln. Okay, wait. It is x square by 2, it is 1 by 2, and it is coming in ln 3 by 2. Okay, it is ln 3 by 2. Okay, so we can say that this area is less than 1 by 2. Okay, this is less than 1 by 2, but it is more than equal to minus 1 by 2. This we have to tell. And we can say that this is more than, this is a positive term. This is a positive term which is more than equal to minus 1 by 2. This is zero point 0.5 and this is 1.5. It is more than 0. If we consider it minus 1 by 2, it will become e to the power 1. So this is less than 2.7. So this is correct. I mean to say that if we are trying to put minus 1 by 2 less than equal to 1 by 2 minus ln 3 by 2. So it will become 1 ln 3 by 2. So can we say that 3 by 2 is less than e to the power 1, which is 2.73? This is correct. So this is correct. Now root sin x we have to prove. So what will happen? Sin x goes somewhere like this. Yes. So at pi by 2 we'll consider 1. Okay. So at pi by 2 x equal to pi by 2. Sin x. Sin x is somewhere like this. Okay, we remember one equality. Sin x is less than x. Okay, and root sin x is less than root x. So we have to go with the estimation of this thing. Yes. Okay, so uh, sin x is less than root x. Okay, at x equal to pi by 2, it is 1, which is less than root pi by 2. Okay, so can we say that at pi by 2 sin x will have maximum value 1 and we are taking root pi by 2. So this area from 0 to pi by 2. Okay, wait. So estimation is difficult at this point only. We have to prove. So if we go by proving this way, we can prove it. Uh, Sine x between 0 to pi by 2, it is a fraction. Yes. So sine x is less than root sine x. Okay. So if we are going to have sine root x graph like this, sine x is this. This is sine x. This is root sine x. Okay. So we can simply say integration of sine x dx 0 to pi by 2 is lower than 0 to pi by 2 root under sine x dx. So this is simply minus cos x. So it is 1 and this is a 1. Now we have to show it is lower. While showing lower, we can say that root sine x is less than root x. So root x value at pi by 2 will be this. Root x value is pi by 2 will be root pi by 2. Okay. What to do? What to do? At pi by 2 it is 1. Root sin x at pi by 2 is 1. So we have to estimate more lower root pi by 2. What should we do? So what can we do is that we have to make root less than root pi by 2. So we can find it is less than 1. But how to find root pi by 2 less than pi by 2? If we do it is 3 by 2. Sin x is less than, we are doing integration 0 to pi by 2 root x dx. So it is simply 3 by 2 pi by 2 to the power 3 by 2 dx. This is the value. Okay. This is simply root pi by 2 2 pi by 3 2 pi by 6, which will go like pi by 3 root pi by 2. So this is 1 point something. Do we have to do something midpoint? I am able to get this thing. Mhm. So I could estimate this thing, it is 1 point something, and it is this. One more thing we can say that a1 is bigger than 1, okay, is less than pi by 2. This is root pi into root pi by 2. So we can estimate only up to this much. So reaching up to root pi by 2 was not possible for us at now, okay. So what will happen in this type of question? 10x by x, okay, 10x by x. So we can say that 10x at pi by 3 is root 3, and 10x at pi by 4 is 1, okay. So 10x by 10x is what? Pi by 4, and this is pi by 3. So this value will be lower than this value and bigger than this value. So integration, it is somewhere y x. 10x by x at this point is what? At pi by 4 it is nothing but 4 by pi, and 10x by x at 3 at pi by 3 is what? 3 root 3 by pi, okay. So what can we do is that this area is what? We have to find this area, and we know that 10x by x is bigger than 1, okay. Pi by 4 to pi by 3, this is 3 root 3 pi, it is dx pi by 4 to pi by 3. So it is somewhere pi by 12. So it is 4 pi multiple of pi by 12. This is a. This is 3 root 3 by pi multiple of pi by 12. So this is less than 3 root 3 pi, okay. So this is telling us that this is more than 1 by 3. and we have to show that this is more than 1 point something. Okay, so this we can prove. Okay, okay, okay. So this is method 1. Method 2. Method 2, it is the same thing. Okay. Hmm. Okay, so let's go by rectangular thing. So at pi by 4, this is pi by 4. 10x by x is increasing function. It is increasing function. Okay. So we are getting this answer. Okay. They have kept integration. So what is the problem? We are getting something like this. This is correct and this is correct. Okay. So this is the question. Sin x by x is decreasing function. Sin x by x is decreasing function. So at pi by 3, it is sin 60 root 3 by 2. So it is root 3 by 2 upon pi by 3. So this is bigger. At pi by 4, it is 1 by root 2 pi by 4. Integrating will give us pi by 12. So see, this time we are getting correct. Okay, so this is what? Oh, it is root 3 by 2. Yes, we are getting root 3 by 8, and it is getting, we are getting 1 by 3 root 2, which is nothing there, nothing but root 2 by 6. So this is what we are getting here. There we were not getting. I think there was some mistake. Now this is x cube. So we know that 3 plus x cube will be uh, so this is integral part. Okay, so it is bigger than root 3 plus x square. So at 1 it is what, 4. Okay, so this is increasing function. So at 1 it is 4, which is 2, and at 3 it is root 30. So integration of root 3 plus x cube dx 1 to 3 is nothing but 2 root 30, and it is nothing but 4. That's simple. Now x to the power 9 x plus 1. So what will happen? We know that 1 upon root 1 plus x is positive. So when it is 0, it will be maximum, and when it is 1, it will be minimum. So now we multiply x to the power 9. So we'll have dx integrating 0 to 1. So this is nothing but, it is x to the power 9. It is nothing but 1 upon 10 root 2. 1 upon 10. The second question. So 1 upon 1 plus x squared is less than 1, bigger than 1 by 2 multiplying 10x. Okay. Multiplying 10x will give us 10x by 2. Integrating with the respect of dx. So we are getting ln sec x 0 to 1. This is a. This is ln sec x by 2, 0 to 1. So we are simply getting ln sec 2 by 2, and this is ln sec 1. Okay. So we have to get it to. Okay. So we have to go with ln. So I felt like if I get ln 2, we can get it something. So let's calculate the value of ln 2. ln sec 2. ln 2 is point something. ln sec 2 is also point something. ln sec 1 is more than 1. So this is what we have to try to find. Okay. 1 plus x square. Try to find the estimation. So these all estimations. Okay. These all estimation you will have to find. So these all are your homework. Okay. So lecture 7 onwards, we have only now one lecture left, which is this mean value theorem and reduction. Okay. So only we have one lecture left, and then we'll come to area under the curve. So by the time we are ending the show,